Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question on gravitational field from May-June 2021 paper 4.1. This question is very important because you will see the same type of questions in many past papers. For this question, it is given to us the Earth may be assumed to be an isolated uniform sphere and the mass of the Earth is given. It is also given to us we can assume that the mass is concentrated at its center. A satellite of mass 1200 kg is in a circular orbit about the Earth in the Earth's gravitational field. The period of the orbit is given, that is equal to 94 minutes. For part A, simply we need to define gravitational field. Part A is simply asking us how strong is the gravitational field. I mean, how we can define that, how strong is a gravitational field. In order to understand that, simply we can sketch this one small sphere. Let's say this is our planet. And there is a unit mass, means the mass of this object is 1 kg. We can simply write down the mass of this one is 1 kg. Now gravitational field simply is telling us how much force is acting on this unit mass, and that is the gravitational field. Means we can find out how strong is the gravitational field. We can also write down the small g is equal to F over small m, force per unit mass. So simply we need to write down here force per unit mass. So that's all what you need to write down for 1 mark. If you write down force per unit mass, you will get 1 mark. And this is B mark for this question. This is B mark, means you have to mention this one in your answer. So this is B mark, you will get 1 mark. For part B, we need to calculate the radius of the orbit of the satellite. So it's a great way to sketch first of all, so we can see the clear picture of this question. Let's say this is our planet and its mass is capital M, and satellite is orbiting around our planet, and let's say the mass of satellite is small m. This satellite is orbiting in a circular orbit around our planet. So this is the orbit. The question is asking us to calculate the radius of the orbit. Radius of the orbit means that this is the distance between the centers of these two bodies. Let's say the distance is equal to small r, and this is the radius of the orbit. This is what we need to calculate. Question is asking us to calculate the value of this radius. Now we need to understand, as this satellite is moving in a circular orbit and it is accelerating, because its velocity means its direction is changing all the time, so it is accelerating. If a body is accelerating, it means there is a resultant force, and in this case the resultant force is provided by the gravitational force between these two bodies. So we can simply write down the gravitational force is providing the centripetal force, provides the centripetal force. But you cannot say gravitational force is equal to centripetal force. Centripetal force is just fancy name for resultant force, and it is not a force by itself. In this case, gravitational force is providing the centripetal force. Now we need to understand, according to Newton's law of gravitation, gravitational force is equal to G capital M small m divided by the distance between centers of two bodies square, and centripetal force is equal to mv squared divided by the distance between centers of two bodies. And so they are the same. If you look at this one, the mass of satellite, we can cancel on both sides, and r we can also cancel. So here we left with G capital M, and this is equal to v square, and v is the orbital speed. Orbital speed v, this is also equal to 2 pi r, means the total distance travel in one cycle divided by the time taken, means this is the time period. We need to plug in values of v square, so we can write down this one here now. This is G capital M over r, and here we can write down this is 4 pi square r squared divided by t squared. Because this is v squared, so I just directly plug in these values. So this is v squared. Now we need to rearrange this one for r. So if we cross multiply, we can write down this is 4 pi square r cube, that is equal to g capital M t square. We need r, so we can rewrite here. R is equal to g capital M t squared. This is the time period divided by 4 pi square. We need r, so we need here the power of this side. This is 1 by 3. Now simply plug in values, we can find out value of r. G, this is constant and its value is given in data, means the value of g you can find in data. If you just check the first page, you can find out the value of data it is given. Its value is 6.67 times 10 to negative 11. This is constant. If you remember, that's wonderful. If you didn't remember, you can just go to data page and you can find its value. M is the mass of the planet, is capital M. The mass is given, that is 6.0 times 10 to 24. And the time period, this is given in minutes. We have to convert into seconds. We can write down 94 times 60, and this is t squared, so this is square, divided by 4 pi squared. So you can plug in value of pi, and we have to take the cube root of this 1 by 3. If we solve this one, we will get our final answer, that will be 6.9 times 10 to 6 meters, up to 2 SF, and that's the answer. This is how you need to do. This question is very common. Try to understand. Always start with this. Gravitational force provides the centripetal force. Then write down the formula, then rearrange the equation, then find out what you need to calculate. This question has 3 marks. Let me explain to you how these marks will be awarded for this question. You will get the first C1 mark if you have equated gravitational force and the centripetal force. You will get first C mark. And the second C mark you will get if you have substituted the values. And the last mark is answer mark, and this is for correct answer. If you got correct answer, you will get this third mark. For part C, it is given to us rockets on the satellites are fired so that the satellites enters a different circular orbit that has a period of 150 minutes. The change in the mass of the satellites may be assumed to be negligible, means there is no change in the mass of the satellite. For C1, we need to show that the radius of the new orbit is equal to this. In order to calculate the radius of the new orbit, we need the expression from part B. In part B, we have derived that gm t square over 4 pi square, this is equal to r cube. R is the radius of the orbit. Let's divide this one first of all by t square on both sides. If we divide by t square on both sides, we can cancel this t square with this one. Then we simply left with gm over 4 pi square, and this is equal to r cube by t square. If you look at left side, here g is a constant, m is the mass of the planet, that is also constant, and pi is also constant. So simply we can write down r cube divided by t square. This is constant, means the ratio between these two quantities r cube and t square is constant. So we can also write down r1 cube over t1 square is equal to r2 cube over t2 square. T2 means this one is for the new orbit. So this is what we need to calculate. We need to calculate the value of R2. You can also understand like this. Let's say this is our planet. Its mass is capital M. We have one satellite, means the satellite, in this case we have just one satellite. First of all, satellite was at point A. Then the satellite moved to point B. In this case, the ratio between the radius, here this one we are saying is, this is R1. This radius is R1. And the time period in this orbit is T1. Now the new radius is R2. This is the new radius. This is what question is asking us to calculate. Radius of new orbit, and it has to be equal to this one. We need to show that it is equal to this. And the time period for the new orbit is given t2. We have the value of t2. So this is t2. So simply we need to find r2. We can rearrange, we can write down r2. This is equal to r1 cube times t2 squared divided by t1 squared, and we need to take the cube root of this, means 1 by 3. Now we just need to plug in values. R1 in the previous part we have calculated, that was 6.9 times 10 to 6. Cube of this multiply with the time period, means t2. Value of t2 is 150 minutes. We need to multiply by 60. Square of this divided by t1. T1 in part B it was given, that was 94 minutes. So again we need to multiply by 60. Square of that. Then we need to take the cube root of this. If we take the cube root, our final answer will be equal to 9.4 times 10 to 6 meters. And this is what we need to show, that the radius of the new orbit is equal to 9.4 times 10 to 6 meters. This question has 2 marks. The first mark is C mark. You will get first mark if you have written this expression. And the second mark is answer mark. You will get the second mark if you have got the right answer. Let's move on to part C2 now. For C2, we need to state with a reason, means state, and we have to write a reason whether the gravitational potential energy of the satellite increases or decreases. First of all, let's look at this point. When the satellite was at this point, let's say the potential energy of the satellite, that is EPA. And when the satellite was at this point, let's say the potential energy, gravitational potential energy of the satellite is EPB. Now we need to explain, is the potential energy EPB is greater or EPA is greater? For that purpose, we need to understand the gravitational potential energy. Gravitational potential energy is simply is equal to G capital M small m divided by R, and R is the distance from the center. If R is greater, EP will be greater. The reason is that because if R is greater, this will be less negative. When this is less negative, it means EP is greater. EP is 0 at infinity. If we look at EPB, this is less negative. This is less negative value as compared with EPA. This is more negative. So we can simply write down this one is more negative. It simply means that in this case, EPB means the gravitational potential energy of the satellite at B is greater than gravitational potential energy of the satellite at A. Because R is greater, if R is greater, it means gravitational potential energy is less negative. So that's the reason. First thing you need to write down increases. We can simply write down gravitational potential energy increases. Second, we need to explain why increases. We can simply write down the reason is that because the separation increases. We can write down separation increases, or you can say the distance from the center of the planet increases. And this question has only 1 mark, and that mark is B mark. For this part, we need to determine the magnitude of the change in the gravitational potential energy of the satellite. First of all, let's try to understand this with the help of one sketch. Let's say this is our planet and its mass is capital M. Satellite was at the beginning at point A, then satellite moved to point B. When the satellite was at point A, let's say the radius of the satellite was R1. And when satellite moved to point B, let's say the radius of the satellite, this is R2. We can also assume that the gravitational potential energy of the satellite when it was point A, let's say this is GPA A, and when the satellite is at point B, its GPE, gravitational potential energy, is GPE sub B. Question is asking us for the magnitude of the change. It simply means the change in gravitational potential energy, GPE, that is equal to gravitational potential energy of the satellite at point B potential energy at point B is greater minus gravitational potential energy of the satellite when it was at position A. Now we also need to understand GPE. This is equal to negative G capital M. This is the mass of the planet, and small m, this is the mass of the satellite, divided by the radius of the orbit. This is R2. When it was at position A, the radius of the orbit is R1. We need to write down this negative sign is very important. This is divided by R1. Now you can see here, if we multiply with negative sign inside, we can write down G capital M small m. Here we multiply, so this will be plus G capital M small m over R1. Now from here we can take G capital M small m, we can take common, then we can write down this is 1 over R1 minus 1 over R2. Now simply we need to plug in values of G, capital M, small m, R1 and R2. Capital G, this is 6.67 times 10 to negative 11, and the mass of our planet is 6.0 times 10 to 24. Mass of satellite is 1200 kgs, and the radius of the orbit when the satellite was at point R1, we have that was equal to 6.9 times 10 to 6. When it was at point B, we have calculated that was 9.4 times 10 to 6. Now simply we need to calculate. If we calculate this one, our final answer will be 1.9 times 10 to 10 joules, and that's the answer. That is the change in gravitational potential energy of the satellite when it moved from point A to point B. Let me explain to you how marks will be awarded for this question. This question has 3 marks. The first mark is if you have written these formulae, you will get first mark. If you have written the formula for gravitational potential energy, this is C mark. First mark. And the second mark you will get if you have substituted these values, you will get second C mark. And the last mark is answer mark. If you have got the right answer, correct answer, you will get the last mark. If your answer is not right, but you have written these steps, means you have written this formula, you have plugged in values, you will get 2 marks. So it's good to write down all the steps and show your working. Welcome to A-Level and AP Physics. In this lesson, we will discuss a kind of typical question on thermal physics from May-June 2021 paper 4.1. For this question, it is given to us an ideal gas is contained in a cylinder by means of a movable frictionless piston as illustrated in figure 2.1. So this is figure 2.1 and this one is piston, and this piston is frictionless. It simply means that there is no friction between the piston and walls of the cylinder. This is our cylinder, these are the walls of the cylinder, so there is no friction between walls of the cylinder and piston. This is what is given to us. It is also given to us initially the gas has volume of 1.8 times 10 to negative 3 meter cube, and the pressure of the gas is also given, temperature of the gas is also given, and this is in kelvins. For part A, we need to show that number of gas molecules in the cylinder is equal to this. In this question, we are talking about ideal gas. It simply means that we can use all ideal gas laws, and also we can use the general gas equation for ideal gases. First of all, let me explain to you the general equation for ideal gases. PV is equal to nRT. Here n is the number of moles. This is number of moles. This small n, this is number of moles. R is gas constant, T is temperature, P is pressure, and V is the volume. We can also write down this one in a little different form. We can write down PV is equal to NKT. N here is number of gas molecules. So this is equal to number of molecules. K is Boltzmann constant, and the value of Boltzmann constant is 1.38 times 10 to negative 23. This is the value, and you can find out this value in data. In data list, you can find out this one. This is given. You don't need to remember this one. This is given in data. Now simply we need to use this equation and we can calculate number of gas molecules. Simply you can write down N is equal to PV divided by KT. Value of P is given, and this is 3.3 times 10 to 5 Pascal, and the volume is given, that is 1.8 times 10 to negative 3 meter cube, and the K is a constant. This is Boltzmann constant. We can write down its value, and this is equal to this one, and the temperature is given. This is in Kelvin. It has to be in Kelvin. So if temperature is given in degrees Celsius, you need to convert into Kelvin. So we can write down into Kelvin. If we solve this one, our final answer will be 1.4 times 10 to 23, and this is the number of molecules. If you prefer to use this equation, you'd simply need to understand N is equal to number of molecules over Avogadro's number. So first you will calculate number of moles, and then you can find out number of gas molecules simply by multiplying number of moles with Avogadro's number. Then you have to use this one. So this will be two step. If you use simply PV is equal to capital N KT, this is just one step. This question has 2 marks. If you have written this formula, you will get 1 mark, means C1. You will get 1 mark. If you have got the right answer, you will also get the answer mark. So there are 2 marks for this question. First mark is for writing the formula, and the second mark is for correct answer. If you have got the correct answer, even you didn't write formula, you will get 2 marks. But if you have written the formula but you got wrong answer, still you will get 1 mark. So it's very important to write down the formula, then plug in values, and then do calculations. For part B, it is given to us we need to use kinetic theory to explain why when the piston is moved, the gas expands. This causes a decrease in the temperature of the gas. For this question, it is given to us the gas expands. It simply means that the work is done by gas, and work done by gas is equal to change in kinetic energy of the piston. So we can simply write down work done by gas is equal to change in kinetic energy of the piston. It simply means that gas is losing energy and the piston is gaining energy. As the gas is losing energy, it also means that the kinetic energy of gas molecules decreases. As the kinetic energy of gas molecules decreases, it also means that the mean square speed also decreases. Now we need to understand how the kinetic energy of gas molecules is linked with temperature of the gas. First thing, we need to understand the average kinetic energy of gas molecules. This is equal to 1/2 m times mean square speed, and this is the mean square speed, and this is also linked with temperature by 3/2 kT. Now from here, this is the average kinetic energy of gas molecule. From here you can see as the kinetic energy is decreasing, it also means that the mean square speed is decreasing. As the mean square speed is decreasing, it also means that temperature of the gas is decreasing. So this is what is happening, and this is all what you need to understand. This question has 3 marks, so you need to write down the 3 points. Let me explain to you now how you can write a proper answer. So here is the answer. This is how you need to write down. First thing, if you have mentioned in your answer the speed of molecules decreases on impact with moving piston. Otherwise you can also say that work done by gas is equal to change in kinetic energy of the piston. So the gas is losing energy. You can also write down in this way, and this is B mark. You will get 1 mark. The second, if you have mentioned the mean square speed is proportional to kinetic energy of molecules, you will get the 2nd mark. As you can see here, this one is the mean square speed, and this is proportional to kinetic energy because mass of molecule is not changing. The third point you need to mention, kinetic energy of molecules decreases, so temperature decreases. You can also see from here, if the kinetic energy of molecules decreases, temperature also decreases. That's all what you need to write down, and this is how marks will be awarded. For part C, it is given to us the gas expands, so its volume increases to this one and its pressure decreases to this. Also, its temperature decreases to 288 Kelvin. It is also given to us the average translational kinetic energy of a molecule, very important. So this is for a molecule of an ideal gas, means if you need to calculate the kinetic energy of a molecule of an ideal gas, simply we can use this equation. In this equation, it is given to us K is the Boltzmann constant and T is the thermodynamic temperature. Thermodynamic temperature means that the unit for temperature we need to use, it must be Kelvin. Question is asking us, we need to calculate the increase in internal energy of the gas during the expansion. For this question, we need to calculate the increase in internal energy for an ideal gas, and for an ideal gas, the change in internal energy is equal to change in kinetic energy of the molecules. We need to calculate the total increase in internal energy. It also means that we need to calculate the total increase in kinetic energy, or simply we can say the change in kinetic energy. In order to calculate the kinetic energy of a molecule, we have this equation that is 3/2 K times delta T. This is for one molecule, but in the gas, let's say we have n number of molecules, so we need to multiply with n number of molecules, and we have already calculated in part A. Now simply we need to plug in values and we can find out the change in internal energy for an ideal gas. Simply we need to plug in values now. So this is 3/2 and K is Boltzmann constant, and the value of Boltzmann constant is 1.38 times 10 to negative 23 joules per Kelvin. We don't need to write unit here right now. Temperature must be in Kelvin. Temperature, initial temperature is 310, but the final temperature is 288. So we can write down 288 minus initial temperature. We need to multiply with number of molecules. Number of molecules we have already calculated in the previous part, and our answer for part A was that is equal to 1.4 times 10 to 23. Now we just need to multiply all and we can calculate the change in internal energy. In this case, our final answer will be minus 64 joules. It means kinetic energy of molecules, or we can say simply say kinetic energy of the gas decreases. This question has 3 marks. Let me explain to you how these marks will be awarded. The first mark will be awarded if you have written this formula. You will get first C mark, and the second C mark you will get if you have plugged in these values, and the third is answer mark you will get if you have got the right answer. But if you have got the right answer and you didn't write these steps in this way, still you will get 3 marks. But if your answer is wrong but you have written these steps, you will get 2 marks, means 2 C marks you will still get even your answer is wrong. So it's very important to write down formula and plug in values. For this part, it is given to us the work done by the gas during the expansion is 76 joules. We need to use our answer in 1 and we need to explain that whether thermal energy is transferred to the gas or the thermal energy is transferred from the gas during the expansion. In order to answer this question, we need to apply first law of thermodynamics. According to first law of thermodynamics, delta U means the change in internal energy. This is equal to Q plus W. Q is the amount of thermal energy and W is the amount of work done. Amount of work done means the work done can be positive, work done can be negative. Work done is positive if the work is done on gas. so that is positive. It simply means that energy has been transferred to the gas. If the work is done by gas, means the gas expand. It means gas is losing energy. If the gas lose energy, work done by gas is negative. We also need to understand when Q is positive and when Q is negative. If thermal energy is added to the system, if the thermal energy has been added to the system, so the Q is positive. I will simply write down, if the thermal energy is added to the system, Q will be positive. If the thermal energy has been removed from the system, then Q will be negative. Means thermal energy lost. Thermal energy lost, we can say, the thermal energy is transferred to the surrounding from the gas. We can also say the thermal energy is transferred to the surrounding. So let me clean and rewrite again. If the thermal energy is transferred to the surroundings, it means the thermal energy is lost. If the thermal energy is transferred to the surrounding from the gas, then in that case Q is negative. That's all what we need to understand. For this question, we have already calculated delta U is equal to minus 64, and Q we need to calculate, and W is the work done by gas. Very important, work is done by gas. It simply means this is negative. From here, we can calculate the value of Q. Q will be equal to 12 joules, and this is positive. So if this is positive, it simply means that energy has been transferred to the gas. Let's try to understand how we can write a proper answer for this question. In order to get 2 marks, the total marks for this question are 2. You need to write down, first of all, decrease in internal energy is less than work done by the gas. As you can see here, the decrease in internal energy, this is equal to minus 64, but the work done by gas, this is minus 76. It simply means that thermal energy has been transferred to the system, means it has been transferred to the gas. So that's the reason we got answer, this is plus 12. This is telling us thermal energy has been transferred to the system, or we can say thermal energy has been added, as already I explained here. If it is positive, it means thermal energy has been added to the system. So this is one point you need to write down, and this is the M mark. It means that it must be in your answer. And the second mark is answer mark. If in your answer you have written that thermal energy is transferred to the gas, you must write down to here, not from. If you write here from, it means you will not get this mark. So 2 has to be in your answer. So this is underlined. It must be in your answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper question from May-June 2021, paper 4.1. And today's question is about simple harmonic motion. For part A, we need to state what is meant by simple harmonic motion. This is very basic question, but it is most frequently asked question in past papers. Almost every year, you will see they will ask you, state what is meant by simple harmonic motion. So we need to be very clear about this one, how we can state simple harmonic motion. Sometimes this question has 2 marks, sometimes this question has 3 marks. Let's try to understand what is meant by simple harmonic motion. In order to understand simple harmonic motion, we need journal equation. Let me write down here first of all the journal equation for simple harmonic motion. Journal equation. A is equal to minus omega square x. A here is for acceleration, so we can write down A here is for acceleration. Omega is the angular frequency, so we can write down this is angular frequency. X is the displacement, so this is displacement. We also need to understand what is meaning of this negative sign. Omega for simple harmonic motion, omega is constant, so we can also write down this is constant. If omega is constant, then simply we can say A is directly proportional to minus x, negative x. As A is directly proportional to negative x, it means that as A increase, we can break down this one into two parts. We can write down A is directly proportional to x. It simply means that when the x is increasing, A is also increasing. The second point we can write down the meaning of negative sign. Sometimes in exam they will ask you what is significance of this minus sign. Significance. So that is very important question. 2 marks question, 1 mark question, they can ask you significance of minus sign. So this is very important point. You need to understand what is significance of this sign and what this sign is telling us. This sign is simply telling us the significance of negative sign. We can draw one small table. Let's say this is over A and let's say this is over X. Negative simply means that when X is negative, A is positive. And when X is positive, A is negative. Let's try to understand what this table is telling us now. According to this table, we have written when X is negative, A is positive. When X is positive, A is negative. What exactly it means? It simply means that acceleration is in opposite direction to displacement. Now we understand what is general equation for simple harmonic motion and how to state simple harmonic motion. We also understand what is significance of this negative sign. Let's try to state what is meant by simple harmonic motion, or simply we can say let's try to write down answer for this question. This question has 2 marks. In exam, if you write down acceleration of the body is directly proportional to its displacement, you will get 1 B mark. If you write down acceleration is in opposite direction to displacement, you will get second B mark, means you will get 2 marks, and the total marks for this question are 2 marks. If this question has 3 marks, then you also need to mention acceleration is always directed towards that fixed point. So you will get another B mark. So you will get 3 marks. But this question is only for 2 marks. If you have written this point and you have written this point, you will get 2 B marks. For part B, a spring mass system is given. As you can see in this figure 3.1, one oscillator is attached at this point. So this is our oscillator. So this one is oscillator. Then a spring is attached. This spring is attached with oscillator and trolley. After trolley, this one is the trolley, and after trolley there is another spring, and this spring is attached with trolley, and it is also attached with the fixed point. So this is the fixed point. As you can see, it is given in the question, attached to a fixed point P, means it cannot move. For this question, it is also given the spring constant is 130 newtons per meter, and mass of the trolley is also given. The mass of the trolley is here. It is also given oscillations of the trolley are simple harmonic motion. We can also find the acceleration A of the trolley by this expression. So here is A and this is X and this is omega squared. So this part is omega squared. So A is equal to minus 2k by m times x. For this question, we need to calculate the frequency of oscillation of the trolley. X is the displacement of the trolley from its equilibrium position. In order to calculate the frequency, we need to compare this given equation with general equation of simple harmonic motion. So let me write down here general equation of simple harmonic motion. Now if we look at these two equations, we can simply find out that omega square here is equal to 2k by m. So simply we can write down here from here omega square, this is equal to 2k by m. 2k by m omega square, but we need to find the frequency. So we need to understand omega, this is also equal to 2 pi f. So this is, we can replace omega with 2 pi f because we need to find the frequency. So we can plug in value of omega. So omega is 2 pi f square. This is equal to 2k by m. We need to find out value of f. We can write down first of all, this is 4 pi square and this is f square. This is equal to 2k by m. We need value of frequency, so simply we can rearrange. So this is 2k divided by 4 pi square m, square root of this. Now simply you need to plug in values. K is given, the value of K is 130 newtons per meter. For pi square, we can plug in value of pi. We need to multiply with mass, but mass is given in grams. If we convert this one into kilograms, we need to divide by 1000, so this will be equal to 0.84 kg. We can write down here, this is 0.84 kg. We need to take the root of this. If we solve this, our value of frequency will be equal to 2.8 hertz. And that's the final answer. This is, we can write down here. Let's try to understand how marks are distributed for this question. If you have written omega square is equal to 2k over m, for this expression you will get first C1 mark. The second C1 mark is if you have written frequency in terms of K and M and you have plug in values, you will get the second C1 mark. And the third mark is for answer, means A mark, and that one you will get if you have got the correct answer, means your frequency is equal to 2.8 hertz, so you will get A mark. This is how marks are distributed: 2 C marks and 1 A mark for the correct answer. Even if your method is different but you got the correct answer, still you will get 3 marks for this question. For part C, it is given to us the amplitude is a maximum at the frequency calculated in B. In part B, we have calculated frequency that was equal to 2.8 hertz. Now we need to understand amplitude is maximum. When the amplitude is maximum, it simply means that system is absorbing the maximum possible energy. Simply we can write down the system is absorbing the maximum possible energy. So I will simply write down energy maximum is absorbing the maximum possible energy, and this will only happen if the driving frequency, in this case the frequency of oscillator, if it is equal to the natural frequency f0 of the system, then system is able to absorb the maximum possible energy. If this is happening, then amplitude also will be maximum. Question is asking us state the name of this phenomenon, and that phenomenon simply we call is resonance. So for this question you need to write down resonance. This question has only 1 mark and this is B mark, means you must write down here resonance, because this marks is independent and it must be seen in your answer. If you simply write down resonance, you will get this B mark, you will get 1 mark. For part C2, it is given to us at any given frequency, amplitude of oscillation of the trolley is constant. We need to explain how this indicates that there are resistive forces opposing the motion of the trolley. First thing we need to understand is amplitude of the trolley, oscillations of the trolley is constant. It means that energy of trolley and spring system, that is constant, so energy of the system is constant, but oscillator is providing energy continuously to the system, but energy of the system is not changing. So what exactly it means? It simply means that energy has been transferred into any other form or work is done against resistive forces. That's the reason energy of the system is not changing. System is not absorbing energy, but energy supplied by oscillator is doing work against resistive forces. Let me explain to you how you can write a proper answer for this question. This is how you can write down a proper answer. First point, you need to write down oscillator supplies energy continuously. This is very important, and this is B mark. it must be in your answer, so this is very important. You have to mention that. Second part, energy of trolley is constant, so energy must be dissipated. This is also B mark, so this also has to be in your answer. If you write down these 2 points, you will get 2 marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question on ultrasound, especially on the use of ultrasound to obtain diagnostic information about internal body structures. This type of question is very common in past papers. You just need to understand few points to answer. For this question, we need to outline the use of ultrasound to obtain diagnostic information about internal body structures. This question is simply asking us how ultrasound is used to obtain information about internal body structure for diagnostic purpose. Means how informations are obtained using ultrasound. First of all, let's try to understand what is acoustic impedance of a medium and what is the effect of difference in acoustic impedance of different media on reflection of ultrasound waves. These 2 points are very important. Let me explain to you first of all what is acoustic impedance. Acoustic impedance, we can use letter capital Z, means the symbol for acoustic impedance is capital Z, and this is equal to rho times C. Z is acoustic impedance. Why we call this is acoustic impedance? Why we don't call this is resistance? In fact, this is resistance of the medium, but we call this is acoustic impedance because in this case, ultrasound waves are not passing through only one type of tissue. They are passing through different type of tissues. That's the reason we call this is acoustic impedance instead of resistance. You need to understand what this symbol rho is representing. This is representing density of the medium. Sometimes in questions they will only ask you what is acoustic impedance. For that purpose, you can write down acoustic impedance is the product of density of medium times the speed of wave in the medium. So this is density of the medium. Rho is density of the medium and C is speed of wave in the medium. Now we are talking about ultrasound. You can say this is the speed of ultrasound in the medium. We can simply write down speed of wave in the medium. So these 2 points, you need to understand these 2 symbols, speed in the medium. Next thing we need to understand, if there are 2 mediums, as you can see here we have gel. Let's say this is medium 1 and this is representing the skin, and let's say this is medium 2. If Z for these 2 media is different, mean if Z1 is totally different than Z2, means Z1 is much greater than Z2. In this case, most of the waves will be reflected. So we can simply say most of the waves will be reflected. Most of the waves reflected. If there is a big difference between acoustic impedance of 2 media. If Z1 is close to Z2, or simply we can say if Z1 is equal to Z2, in this case no reflection takes place. No reflection, you can simply say, occurs if 2 media they have the same acoustic impedance. We can also understand in a different way, means in one medium acoustic impedance is the same, so there is no reflection in single medium. We can also understand this one by intensity reflected divided by intensity, means incident intensity. This is equal to Z2 minus Z1, means the difference between acoustic impedance of 2 media, square of that divided by the square of the sum of the acoustic impedance. Now in this case you can see if Z1 is equal to Z2, this will be 0. It means no reflection. If Z2 is much bigger or Z1 is much bigger than Z2, in this case most of the waves will be reflected. Very important point, we need to understand this. Let's try to understand why doctors use gel on the skin of patient. Means any patient who go for ultrasound, they will use gel on the skin of the patient. As you can see here on the belly of this pregnant woman, there is a gel and here is ultrasound probe, and this is a little press inside. That is also very important. It's little bit pressed inside. Let me explain to you this one with help of this very simple figure. You can see this is the gel actually. This is the boundary of the gel, and you can see this all is gel on the skin, and this black line, this is representing skin. Why do we need to apply this gel? This gel actually, this is acting as a coupling medium. It means it is coupling two different media. I mean, it is coupling air with skin. That's the reason we call this is coupling medium. And the purpose of this one is to reduce impedance change between two media. Impedance change, it reduces impedance change. So very important point to understand. Let me explain to you little more about ultrasound before we write our final answer. First thing you need to understand is the probe. As you can see in this figure, this is representing the probe. So this black one, this is representing the probe. In this figure, you will see the whole process. So this is the probe. You can also simply understand this one is the probe. And the purpose of probe is to transmit ultrasound pulses and also to receive ultrasound pulses. In exam, sometimes they can ask you why ultrasound waves are emitted in pulses. Because the probe is acting as a transmitter and it is also acting as a receiver or detector. That's the reason ultrasound waves are emitted in pulses. Next, if you look at the next one, blue one, this is gel. This is placed on the skin, and this is acting as a coupling medium as we have already discussed. And next is the skin. This gel and skin, the acoustic impedance is almost same, so simply we can say all the ultrasound, they will enter the body and there will be no reflection. But when these ultrasound pulses, they will reach this tissue, there is a change in medium. Some of ultrasound will be reflected back from this boundary, and amount of reflection is very important. Amount of reflection tells us information about boundary, means the nature of boundary. We can write down amount of reflection gives us information about nature of boundary, or simply we can say about type of tissues. So very important point to understand. About nature of boundary, or we can say about type of tissues, because different tissues, they have different acoustic impedance. If there is greater amount of reflection, it means there is a big difference between acoustic impedance of two media. If less reflection, it means the acoustic impedance is almost same. Then these ultrasound waves, they will continue traveling in this medium. There will be no reflection because there is no change in acoustic impedance. So when these ultrasound pulses, they will reach at this point, again reflection will take place. So some of ultrasound waves, they will be reflected back. So they will be reflected back. Now, based on the delay time, means first of all, this will be reflected back. This will reach detector. But these ultrasound waves, they will continue traveling forward. But at this point, they will reflect back. And then they will reach the detector. So there is a delay time. And delay time, we can simply say this is delta t. And that is the time it will travel in this tissue from here to here and then back from here to here, and that is the difference or the time delay when these two pulses are detected by this. I mean, this is the first pulse detected and this one will be the second. So there is a time delay, that is delta t. Based on this time delay, we can find the thickness of the tissue if we know the speed of the wave in the medium. So simply we can say thickness will be equal to speed times delay time, means the gap of time between two pulses divided by 2. So we can find the thickness of the tissue. And this ultrasound wave, in these pulses, they will continue. When they will reach this boundary, again there will be reflection from this. Again, we can determine the thickness of the tissue or part of the body, and also we can determine the nature of boundary. That's all what we need to understand before we write our final answer. This is how you can write a proper answer. It simply means that you can write your answer in a little different way, but these points has to be in your answer. In your answer, if you have mentioned ultrasound pulse, you will get 1 mark. So this is B mark. If you have mentioned about reflected at bound rays, you will get second B mark. If you have mentioned about the use of the gel, it is used to minimize reflection at skin, you will get the third B mark. And the fourth mark you will get if you have mentioned about time delay between generation, means between transmission of ultrasound pulse and detection gives information about the thickness, you will get the fourth mark. And the fifth mark is about intensity of reflected waves, means the amount of reflection gives information about nature of the bound ray. If you have written this one in your answer, you will get the last fifth mark. You will get total 5 marks if you have mentioned these 5 points in your answer. And this is typical type of question, so it's better little bit practice and try to remember these points. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question from communication systems. And this question is from May-June 2021, paper 4.1. For part A, we need to state what is meant by the amplitude modulation of a radio wave or any type of wave. Let's try to understand what is amplitude modulation. This is our signal. So simply let me write down here. This is the signal. And this is carrier wave is already written here. So this is carrier wave. And this is amplitude modulated wave. If you look at this one, when the displacement of signal, this is positive, the amplitude of amplitude modulated wave is greater than the carrier wave. That when the amplitude of signal is negative, the amplitude of amplitude modulated wave, this is smaller than the amplitude of carrier wave. From here simply we can say that the amplitude of carrier wave changes depending on the displacement of the signal, and that is amplitude modulation. We can also look at this one. You can see this is modulating signal here, and we have here amplitude modulated carrier wave. You can also see when the displacement here is positive, the amplitude of this modulated carrier wave is greater. But when the displacement of signal is negative, amplitude of amplitude modulated carrier wave is smaller, and so on. So amplitude modulation simply means that the amplitude of amplitude modulated carrier wave depends on displacement of the signal. Let's try to define how to write what is meant by amplitude modulation. This is how you can write down amplitude modulation. There are few points you have to be very clear. You need to mention where is in synchrony, means the amplitude of the carrier wave, where is in synchrony with displacement of the information signal. So these things you need to mention to get 2 marks for this part. For part B1, we need to calculate the wavelength of the carrier wave. First of all, we need to understand what is this frequency. This is frequency of carrier wave. Often we write down this is FC. This is frequency of carrier wave. And this upper sideband, this is frequency of carrier wave plus the frequency of signal. And this frequency, this is equal to the frequency of carrier wave minus frequency of information signal. So these are the points we need to understand. So this is also called lower sideband. Let me write down here. This is lower sideband. This is the lower sideband, and this is upper sideband. So this is upper sideband. We also need to be familiar with these names. So this is upper sideband. We need to find the wavelength of the carrier wave, but we have the frequency. The frequency of carrier wave, simply we can write down. This is 300 kilohertz. Be careful with the unit. So this is 300 kilohertz. kilohertz. So simply we can write down this is 3.0 times 10 to 5 hertz. So this is the frequency of carrier wave. Now we need to find out the lambda for this carrier wave. We need to divide the speed of the radio waves, that is equal to speed of light, divided by the frequency of this carrier wave. Speed of light means this is Vc, this is the speed of light, that is simply equal to 3 times 10 to 8 meters per second. But the frequency of the carrier wave we have, that is 3.0 times 10 to 5 hertz. So simply our final answer will be equal to 1000 meter. So this is the wavelength of carrier wave. Now for the next one, we need to find out the bandwidth of the modulated wave. Bandwidth is the range of frequencies occupied by modulated wave. So the bandwidth simply is the range of frequencies occupied by modulated wave. Range of frequencies. You have to be clear with this. Range of frequencies occupied by the modulated wave. So range of frequencies. Now the question is that how we can find that range of frequencies. So the range is this one, means the upper sideband minus lower sideband. This range is called the bandwidth. So this is the bandwidth. This is bandwidth. Simply this is. So in this case we have 308. So we can write down 308 minus 292. So that is simply 308 minus 292 kilohertz, and that is equal to 16 kilohertz. So this is the bandwidth. We can also write down here, this is the bandwidth. So this is how you need to find out bandwidth. Very common question from this chapter. Next one, the maximum frequency of the audio signal. We need to find out the maximum frequency. Now you can see here, this is the frequency of the carrier wave, and this is the frequency of carrier wave plus signal. So from here we can find out the frequency of signal. This is simply equal to frequency of carrier wave plus frequency of signal minus frequency of carrier wave. So simply this is 308 minus this is 300. So our final answer is 8 kilohertz. This is the maximum frequency of information signal, maximum. So this is 8 kilohertz. For part C, the power of a radio signal at a transmitter is given, and that is equal to PT. At a receiver, the received power is given by the following expression. PR is equal to 0.082 PT divided by x square. So this x square. X is the distance here, and this is in meters between the transmitter and the receiver. If x increase, PR will decrease. For the transmission of the signal, attenuation is also given, and that is equal to 73 dB. We need to find the distance x, and answer has to be in meters. This question is simply about attenuation. So this is all about attenuation. So simply we need to write down the formula for attenuation. In this case we will place P in numerator, so our answer will be positive, mean x will be positive, divided by P out. You can also place P out by P in, so then this has to be negative. Attenuation is given, the value of attenuation is given, so that is equal to 73 dB. So simply this is 10 log. We can also draw like this. So let's say this is transmitter, so this is PT, and after a certain distance here we have a receiver, the power is PR, and this is the distance between them, and attenuation between transmitter and receiver, that is 73 dB. P1, so in this case our P input, so we can write down this is P input, and this is the power out at receiver. Now the Pin is equal to PT, so simply we can write down this is PT. But PR, this is equal to 0.082 PT divided by x squared. So this is x squared. We need to simplify this. If we simplify, we can write down like this. So this is 10 log. We can write down this is x squared PT divided by 0.082 PT. Now as PT is common, we can cancel this. We simply left with 10 log x squared divided by 0.082. Now simply we have to simplify this one. We can write down here 73 divided by 10. So this is 73 divided by 10. This is equal to log x squared divided by 0.082. Now we can simplify here. We will get this is 7.3 and this is log x squared divided by 0.082. Now simply we need to find value of x from here. The next step we can write down that will be equal to, we can write down this is 10 to the power, this is 7.3 and this is equal to x squared divided by 0.082. From here we can find out value of x. X will be equal to 1300 meters, and this is our final answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electric field from May-June 2021, paper 4.1. In this lesson, we will discuss how to sketch electric field against distance for an isolated matter sphere. I will also explain you how to sketch de Broglie wavelength of a particle against its momentum. At the end of the video, we will also discuss how to sketch the number of daughter nuclei against time. For part A, it is given to us an isolated metal sphere of radius r and electric field at its surface is given, that is E naught. This sphere is charged and electric field at its surface is E naught. For this question on figure 6.1, we need to sketch the variation of electric field E against distance x from the center of the sphere. We need to sketch from x is equal to 0 to x is equal to 3r. First of all, let's try to understand how the electric field of metal sphere look like. If you look at this metal sphere, you can see there is electric field that is outside of the metal sphere, but there is no electric field line inside this metal sphere. This is simply telling us that there is no electric field inside metal sphere. Later we will discuss why there is no electric field inside metal sphere. First of all, let's try to look at the electric field outside of the metal sphere. Electric field outside of the metal sphere we can relate with distance from the center of the metal sphere by this simple relationship. E is equal to kq over x squared, and x is the distance from the center of the metal sphere. Now if you look at this equation, we can simply rearrange this one. We can write down Ex squared, this is equal to kq. Q is the amount of charge on the metal sphere that is constant, and k is also constant. It simply means that the product of E and x squared, this is constant. So simply we can write down this is constant. We can also say that it simply means that electric field E1 at distance x1 squared, this will be equal to E2 times x2 square, and this is also equal to E3 times x3 square. Now what exactly it means? Let's say when the distance from the center of the sphere that is equal to r, means just at the surface, so we can say simply at this point, then electric field is equal to E naught, and this distance is r. So this is r square. Let's look at a point that is at a distance of 2r. As you can see here, x is equal to 2r, so electric field at this point is E2. Now as the distance is double, so this is our electric field E2, distance is double, so means this is 2r square. This has to be E naught divided by 4 because the product has to be the same. If we take another point, let's say we take this third point that is at a distance of 3r from the center of the sphere, from the center of metal sphere, then the value of E3 that will be equal to E naught by 9 because the distance is triple. In this case, now we have found the value of electric field at the surface, that is E naught. This is already given to us that the electric field at its surface means at a distance of r that is equal to E naught. That's the reason we have written this is E naught. If the distance is double from the center of the sphere, electric field is 1/4, and if distance is triple, is 3 times, electric field is equal to E naught by 9. So these are the points we need to understand to draw electric field outside of metal sphere. Let me show you how to sketch. You can see here at distance r, electric field, this is E naught, so electric field here, this is E naught. At a distance of 2r, electric field is E naught by 4, so electric field here is E naught by 4, means 1/4 of electric field at the surface. And at a distance of 3r, electric field is E naught by 9, and then we need to sketch this curve. This is what you need to do for this question for the electric field outside of metal sphere. Let me explain to you why the electric field inside the metal sphere, this is equal to 0, means electric field here, means from the center to the surface, electric field inside this metal sphere, this is equal to 0, as I have already explained here. Let me explain to you this one with very simple example. Let's say we have this metal sphere and we add some charge on this metal sphere. Let's say this is the charge we have added on this metal sphere. What will happen is that this charge will not stay here. You need to understand the reason is that because this is metal, this is a conductor, so these charges, there is repulsive force between these charges will repel each other, and finally these charges, they will stay at the surface of the metal sphere, and these charges, they will be evenly distributed, and when they are evenly distributed, finally the electric field inside this metal sphere, that will be equal to 0 because these charges inside the metal sphere, they will cancel electric field, so there will be no net electric field inside the metal sphere. But these lines outside of the metal sphere, they appears to come from the center of the sphere, but inside the sphere, electric field is cancelled. Mean these charges, they cancel electric field of each other, and when they're evenly distributed, there will be no net electric field inside metal sphere. So this is what you need to understand. We can also understand this concept in a little bit different way. We can also use Gauss's laws, we can also use, but this is not part of A level. But if you're curious about this one, we can also use Gauss's law. According to Gauss's law, the closed integral of E dot dA, so E is electric field and A is the area normal vector, this is equal to Q enclosed divided by E epsilon naught. Q enclosed, this is the charge inside Gaussian surface. If we draw our Gaussian surface here, inside the metal sphere, there is no net charge enclosed inside this Gaussian surface, so it means Q is equal to 0. So if Q is equal to 0, it means electric field is equal to 0. So this is mathematical proof of this, why electric field inside metal sphere is 0. Let's try to understand what will happen when we place a neutral metal sphere inside an external electric field. As you can see here, when we place this metal sphere inside electric field, electrons will be attracted in direction opposite to the electric field. So you can see here this side become more negative and this side become more positive because this has less number of electrons. So in this case you can see the positive charge is on one side, negative charge is on the other side. So there is an induced electric field that is inside this metal sphere, and this induced electric field, this is opposite to the external electric field, and this induced electric field will go on increasing until the magnitude of induced electric field is equal to external electric field. Means the magnitude of these two electric fields finally will be equal. So when it is equal, so these two electric fields, they will cancel each other, and the net electric field, let me draw the lines inside. You can see this is external electric field and the red one, that is induced electric field. So when the magnitude of these two is equal, then the net electric field inside metal sphere, again this will be equal to 0. So this is example of shielding. So electrostatics shielding, so this is E, this is equal to 0. So in this case electric field inside metal sphere is also 0 when we place this one inside an external electric field. Same concept we can also use to explain this one, mean an isolated metal sphere, why electric field inside isolated metal sphere is equal to 0. Let me explain to you how marks are distributed for this question. If you have shown from x is equal to 0 to x is equal to r, electric field is equal to 0, mean if you have drawn this horizontal line, you will get 1 mark, and this is B1 mark. The second mark you will get if you have drawn curve that has negative gradient of decreasing magnitude, means you have drawn the curve like this, you will get the second B mark. And the third mark you will get if you have shown at distance of 2r electric field is E0 by 4, and you have also shown that at a distance of 3r electric field is equal to E0 by 9, then you will get the third B mark. So this is how marks are distributed for this question. For part B, it is given to us the de Broglie wavelength of a particle is lambda naught when its momentum is p naught. On figure 6.2, means on this figure we need to sketch the variation with momentum of the de Broglie wavelength of the particle for values of momentum from p naught by 2 to p naught. So this is p naught by 2 to p naught. In order to sketch graph between these two quantities, we need to understand the relationship between wavelength and momentum, and that is simply equal to lambda is equal to h over p, and p is the momentum of the particle and lambda is the wavelength of the particle. It is given to us the de Broglie wavelength of the particle is lambda naught, simply let's say this is lambda naught, and the momentum is p naught. At this wavelength, this is the momentum. If we rearrange this one, we can write down lambda naught p naught, this is equal to h. H is a Planck's constant, so this is constant. Simply we can write this is constant. Next thing we also need to understand, when the momentum is half, means this momentum of the particle, this become half. Lambda, this has to be double, 2 times of lambda naught, because the product of these two quantities, it has to be equal to h. This is what we simply need to understand. So these two quantities we can also understand. We can write down here lambda, this is inversely proportional to momentum of the particle. We can also write down like this. Now we need to sketch the graph between these two quantities. Graph will be rectangular hyperbola. So let me show you how you can sketch the graph. This is how you can sketch the graph. This is simply how you need to sketch. And for this question, there are 2 marks. Let me explain to you how these marks will be awarded. The first mark is if you have drawn a curve with negative gradient of the decreasing magnitude, and it is passing through p naught and lambda naught, and its gradient is negative and gradient is decreasing. And the second, so this is 1 mark, so this is B mark. You will get 1 mark. And the second mark you will get if your line is passing through P naught by 2 and 2 lambda. So this is P naught by 2 and 2 lambda. So this is P naught by 2 and this is 2 lambda. So this is the second mark. This is second mark. So the first mark P naught lambda naught. So this was the first mark. You got 1 B mark. If you have drawn the line, means you have drawn this curve and its gradient is negative and gradient is decreasing and it is passing through this point. You got 1 B mark. And if it is passing through 2 lambda naught and P naught by 2, you got the second B mark. So this is the second B mark. For part C, it is given to us a radioactive isotope decays with a half-life of 15 seconds to form a stable product. The radioactive isotope at time t is equal to 0 contains n naught number of nuclei and there is no nuclei of the stable product. Question is asking us to sketch on figure 6.3 the variation with time of the number of nuclei of the stable product for time t is equal to 0 to t is equal to 45 seconds. T is equal to 0 here and t is equal to 45 seconds here. We need to sketch on this figure 6.3. In order to answer this question, first of all, let's draw one simple table and then we will sketch this graph. Let's say we have 3 different columns. In the first column we have time and in the second column we have number of parent nuclei. This is number of parent nuclei, and in the third column, let's say we have number of daughter nuclei, or simply we can say product nuclei. I will simply write down number of product nuclei. So this is number of product nuclei. At time t is equal to 0, there are only parent nuclei, so that is equal to n naught, and there are no any product nuclei, so this is 0. After time equal to 1 half life means t1 by 2, this become half, means this become n naught by 2, and the daughter nuclei are the product nuclei, they also equal to n naught by 2. We can also say this is equal to 0.5 of n naught. After 2 half lives means 2 times of 1 half life, this will decrease to n naught by 4, and the product nuclei, they will increase to 3n naught by 4, or we can say that that will be equal to 0.75 of n naught. After time equal to 3 half lives, so 3 half lives, this will decrease to n naught by 8, means the parent nuclei, and the number of daughter nuclei, they will increase to 7 n naught by 8. So this is just basic calculations based on half-life, and that will be equal to about 0.88 n naught. So this is about, actually the exact number is 0.875. Approximately we can write down 0.88 n naught. That's all what we need to understand, and now we need to sketch. It tells us after 1 half life, means after 15 seconds this become half, so this will be here, so this become half. And after 2 half lives, this is 0.75, means this is after 2 half lives, so this will be here. And after 3 half lives, this will be 0.88, so that will be around here, 0.88, and then we just simply need to sketch. Let me show you how you can sketch the graph. This is how you need to sketch, and this question has 3 marks, so let me explain to you how the marks will be awarded. You can see the first mark will be awarded from time t is equal to 0 to t is equal to 45
5 seconds, mean from here to here, if you had drawn the curve with positive gradient, as you can see the gradient of this line is positive but the gradient is decreasing, and it has to start at 0, 0, means if it is starting from here, so you will get 1 mark. So this is B1, 1 mark. If the line is passing through 15 and n0 by 2, means if the line is passing through this point, you will get the second B mark. And the third B mark is if the line is passing through 30, 0.75 n naught and 45, 0.88 n naught, when it's passing through this point, we will get the third B mark. This is how marks are distributed for this question.
Welcome to A-Level and AP Physics. In this lesson, we will discuss important past paper question on capacitance from May-June 2021, paper 4.1. For part A, simply we need to state what is meant by the capacitance of a capacitor. In order to understand capacitance, we need to understand Q is equal to CV. Q is the charge on single plate, or simply we can say this is the charge on one plate of capacitor. Simply we can say charge on one plate. C is the capacitance of a capacitor, and capacitance simply means that this is the ability of a capacitor to store energy. If the capacitance of a capacitor is greater, it means capacitor is able to store more energy. If the capacitance of a capacitor is lower, it means capacitor is not able to store a lot of energy, or simply you can say it has ability to store less energy. So this is about capacitance. Let's try to understand what this symbol is representing. This symbol is for the potential difference between the plates. Simply we can write down potential difference between the plates of a capacitor. So this is potential difference. We can also understand with the help of the symbol of capacitor. So this is the symbol for parallel plate capacitor. Let's say this plate is positively charged and this plate is negatively charged, and the net charge on this plate is plus Q, and the net charge on this plate, this is negative Q. So this Q simply means that you need to take the charge on one plate. If we look at the charge on these two plates, the net charge on these two plates, the net charge on these two plates means the net Q, that is plus Q minus Q, that is equal to 0. So it simply means that capacitor does not store charge. Capacitor store energy. Very important point. Now what does it mean by the potential difference? Potential difference simply means that this is the potential difference between these two plates, and you can find out this potential difference by simply connecting voltmeter across these two plates, or simply between these two plates. This is what you need to understand about capacitance. Let me explain to you how you can write a proper answer to get 2 marks for this question. In your answer, first thing you need to mention that capacitance is equal to charge over potential. You can also say charge over potential difference. If you have mentioned this one in your answer, you will get 1 mark, and this is M mark. It means that it must be in your answer. The second, in order to get the second point, you need to mention charge is on one plate. Simply means that you need to explain what do you mean by charge here. Then you need to explain what do you mean by potential. So potential is the potential difference between the plates, and charge is charge on one plate. As I have already explained to you, the Q is the charge on one plate and V is the potential difference between the plates. From here, simply you can write down C is equal to Q over V, and then you need to explain what is Q, what is V. So the Q is charge on one plate and V is potential difference between the plates. For part B, it is given to us a capacitor of capacitance capital C is connected into the circuit as shown in figure 7.2.
0.1, as you can see here. It is also given to us when the two-way switch, mean this two-way switch, it is in position A, the capacitor is charging, means when it is connected like this. The capacitor is charging, and when this capacitor is fully charged, the potential difference across capacitor is equal to the potential difference across the power supply. Simply, it is equal to capital V. But when we move this switch to position B, this capacitor will start discharging. Question is asking us B1. For B1, we need to show that the average current in the ammeter is given by the expression I is equal to FCV. In order to prove that I is equal to FCV, we can simply start from Q is equal to CV. Now, if we divide both sides by T, and T is the time taken for a capacitor to charge and discharge, then simply you can see on the left side we have Q over T, and Q over T, this is equal to I. If we look at right side, we can also rearrange. We can write down like this. Now 1 over T, this is simply, you can understand, 1 over time period, and that is equal to the frequency. We can write down small f. So finally, we have got I is equal to FCV. This question has 2 marks. This derivation, you have included Q over T, you will get 1 mark, and that is M1 mark. This must be in your derivation. And the second mark you will get if you have got this correct answer, and that is A mark. For part B2, it is given to us the potential difference is equal to 150 volts and frequency is equal to 60 hertz. Average current in the ammeter is given, that is equal to 4.8 microamps. We need to calculate the capacitance in picofarad. This question is pretty straightforward one because it is just simply based on part B1. In part B1, we have derived this expression I is equal to FCV. Now this question is asking us to calculate C, so we can rearrange this expression. We can write down C is equal to I over F times V, and we can plug in values. I is given, the value of I is 4.8 times 10 to negative 6 amps, and this is divided by the frequency. Magnitude of frequency, or simply the value of frequency, is equal to 60 hertz, and potential difference is equal to 150. Now if we solve this one, we can get the value of capacitance. That one will be equal to 530 picofarads, and that's the final answer. Simply we need to write down 530 picofarad. This question has 2 marks. The first mark, you will get the C mark if you have rearranged this equation and you have plugged in these values, and the second mark is A mark. This is answer mark you will get if you have got the right answer. So there are 2 marks for this question. Even if your answer is wrong but you have written this one, you will get C mark. But if you got the right answer, you haven't written in this way, still you will get 2 marks. So it is very important to show your working. Even your answer, for example, for this part is wrong, but you have shown this one, so you will get 1 mark. So always write down the formula, then show your working and plug in values. For part C, it is given to us a second capacitor having the same capacitance as the capacitor in part B is connected into the circuit of figure 7.1. The 2 capacitors, they are connected in series. We need to state and explain the new reading on the ammeter. In order to answer this question, the first thing we need to understand, when we connect another capacitor in series with the first one, what is the total capacitance of this circuit? As these 2 capacitors, they have the same capacitance, they are identical and they are connected in series, so the total capacitance of the circuit, that will be equal to C by 2, means it becomes half. But the potential difference is the same, so simply we can understand then from Q is equal to CV, we can write down the C is equal to Q by V. But V is the same. If C become half, it means Q also becomes half. So this is the main point we need to understand. Now we can understand I is equal to Q over T, and If time is the same but the charge is half, it means I is half. We can also understand this one simply from the formula we have already derived. I is equal to FCV. In this case, F is the same, V is the same. If the C become half, it means I becomes half. That's all what we need to understand. It simply means that current will be half. Before, the value of current I naught, that was equal to 4.8 microamps. Now it becomes half. It simply means new value of current, this is equal to 2.4 microamps. And charge is half because capacitance is half. Or you can say current is half because capacitance is half. You can also explain this one. You can say as F and V, they are same. When the capacitance becomes half, I also becomes half. That's all what you need to understand and you need to write down to answer this question. Now let me explain to you how you can write a proper answer. This is how you can write a proper answer. The first point, if you have written 2.4 here, you will get 1 B mark. The second B mark you will get if you have written total capacitance is half. The third one you will get if you have mentioned charge becomes half. Or you can say F and V are constant, current becomes half. Or you can say current is proportional to capacitance. That's all what you need to write for this question.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important question on operational amplifier, and this question is from May-June 2021, paper 4. For question number 8, the variation with temperature of the resistance of a thermistor is shown in figure 8.1. This is figure 8.1. You can see here on y-axis resistance is plotted and its unit is kilo ohms. On x-axis temperature is plotted and its unit is degree Celsius. For this question, it is also given that a student includes the thermistor and an ideal operational amplifier in the circuit of figure 8.2. This is our figure 8.2. You need to understand the name of these components, mean the names of these certain components. First of all, the name of this component, you need to be very clear with this symbol because this symbol is very common and this is for thermistor. The second symbol you need to understand is this is symbol, and this symbol represents LED, light emitting diode, and this is our output device. These are just resistors as you can see, and this is op amp. For part A, question is asking us we need to calculate the potential V plus at the non-inverting input. Non-inverting input, if you look at op amp, it has two inputs, one with positive sign, that is called non-inverting input. So this is non-inverting input. If V plus is greater than V minus, then V out will be positive. So V out will be positive. So it means current will flow like this. So this is very important. When V out is positive, so means current will flow like this. The second one with negative sign, this is inverting input. We need to understand these things are very important. Even we don't need for this question right now, but you need to understand. So this is inverting input. It simply means if V negative is greater than V plus, V out will be negative. V out will be negative means current, if V out positive, current will flow like this. But if V out is negative, current will flow in opposite direction, means current will flow like this. If V out is negative, so current will flow in opposite direction. So this is very important. You have to be clear with these things. Now let's try to find out what is the value of potential at non-inverting input. If you look at this point and we look at this point, potential at this point, this is equal to 0 volt. If I connect voltmeter across these 2 points, means across this resistor between these 2 points, so the reading on this voltmeter, let's say that reading is equal to V1, and that is the potential at this point.
Why? Because this side potential is 0. So the potential difference across this one, that is equal to potential at this point. Now simply we need to find out V1. So V1, simply we can say that, or if you want to write down V plus, we can also write down this is V plus. V1 in this case is equal to V plus. V plus simply is equal to resistance of this resistor divided by the total resistance of this branch. So we can say this is 3 ohms divided by 3 kilo ohms plus 2.5 kilo ohms. We don't need to write kilo because it will be cancelled. Then we need to multiply with this potential difference across these two resistors, and that is 3 volts. If we just simplify this, we will get our final answer, and that is the value of V plus, and this is 1.6 volts. So V plus is equal to 1.6 volts. For part B, at 10 degrees Celsius, the resistance of the thermistor is 2.5 kilo ohms. Question is asking us to state and explain whether the LED is emitting light or not. Simply we need to answer, is it emitting or is it not emitting light? How we can justify that one, it is emitting or it is not emitting light? For that purpose we need to understand, because this LED, it is connected in this way. This is diode, and the resistance of diode in this direction is very low. So if current flow like this, then this LED will emit light. In order for current to flow like this, V out means the V out of this op amp has to be positive. So in that case it will emit light. Simply we can write down, it will emit light. On other hand, if V out, let's say if the V out is negative, then current will flow this way, but the resistance of LED is very high in reverse biased, so no current will flow. So when no current will flow, it will not emit light. So simply we can write down does not emit light if V out is negative. So simply we can say does not emit light if V out is negative. Now we need to find out, is the output of op amp, is it positive or is it negative? We have calculated value of V plus, and that V plus in part A, that was equal to 1.6 volt. Now simply we need to find out what is value of V minus. The resistance of this thermistor is given now, and the resistance of this one, we can say this is RT, that is equal to 2.5 kilo ohms. Now we need to find the potential at this point. If we connect our voltmeter across this, means across this resistor, and this is one end of the resistor, we need to find the potential at this point, and this end, this is connected with ground, so this has 0 potential. So the reading on this voltmeter is simply equal to V minus. Let's try to find out what is potential difference across 5 kilo ohm resistor. So we can say that this is V minus, and this will be equal to 5 divided by 2.5 plus 5. Simply we need to multiply with the potential difference across these two resistors, that is equal to 3.0 volts. In this case our final answer is 2.0 volts. So V minus, this is equal to 2.0 volts. For this question we need to state and we need to explain. State means that we need to write down it is emitting light or it is not emitting light. So we simply write down here does not emit light. So you can say simply no light, or you can say does not emit light. So this is what you need to state, does not emit light. This is one thing you need to write down. We need to explain that why it does not emit light, means we need to write down explanation. So we will explain here now. We have to give reasoning. We need to justify our answer why it is not emitting light. So the first reason you can write down as V minus means this one. V negative, this is greater than V positive, means V positive. So the second point you can write down, output is negative. So that's the reason it does not emit light. Output is negative. So we can write down here output is negative. State does not emit light.
Explain why not emit light? Because V negative is greater than V positive and output is negative. For part C, we need to explain why the student circuit will not indicate any change in temperature above 0 degrees Celsius. First of all, we need to understand what does it mean by change and when we will observe change. Change means that LED switch on or switch off. LED switch on and switch off. So simply we can say the change means that LED is on, then LED is off. Or LED is off, then it is on. So that will indicate there is a change, and that is depending on change in output. Means V out, this change will happen when V out change from positive to negative or change from negative to positive. So vice versa is also true. So it changed from positive to negative or V out change from negative to positive. When V out is negative, LED will be off, and when V out change from negative to positive, LED will switch from off to on. So means LED will change from off to on. But when output change from positive to negative, LED will change from on to off. Simply we can say this LED is depending on V out, or we can say it is depending on V positive and it is depending on V negative. V positive and V negative, because V positive, if this is greater than V negative, V out will be positive. If V negative, this is greater than V plus, V out will be negative. Now we need to understand what is value of V negative at this point. Means V negative, this value we need to find out. V positive we already have because this is constant potential at this point, because we have to fix resistors here. And V positive, this is equal to 1.6 volts. But for this question it is given to us at 0 degrees Celsius. At 0 degrees Celsius, resistance of thermistor, this is equal to 3.8. So we can write down the resistance of this thermistor is equal to 3.8 kilo ohms. Resistance of this resistor we have because this is a fixed resistor. Now we need to find out the potential at this point. Again, simply we can say if we connect our voltmeter across this 5 kilo ohms resistor, so the reading on this voltmeter, that will be equal to V negative. V negative. Now the question is that how we can find out this. Simply we can write the resistance of this resistor 5 kilo ohms divided by 5 kilo ohms plus the resistance of thermistor, that is 3.8. We need to multiply this one with the potential difference across these two resistors, and that is equal to 3.0 volt. If we solve this one, our final answer will be 1.7 volt. Then this is the value of V negative. Now we need to understand, as temperature will increase, question is telling above 0 degrees Celsius. Now as temperature will increase, the resistance of thermistor is decreasing. Mean this number will go down. If this goes down, this will go up. So it simply means that the value of V negative will be greater than 1.7 at higher temperatures. Then we can simply write down at 0 degrees Celsius, V negative, this is equal to 1.7 volts, and V negative always will be greater than V plus at higher temperatures, will be greater than V plus at temperatures higher than 0 degrees Celsius, at temperatures above 0 degrees Celsius. It means that we can say therefore V out is always negative. So the V out is always negative. It means that LED is always off. We will not observe any change. LED is off all the time. So we will not observe any
change. For part D, the resistor of resistance 5 kilo ohms is changed to a resistor of resistance capital R so that the LED switches on or off at a temperature of 20 degrees Celsius. At a temperature of 20 degrees Celsius, LED switches on or off. It simply means that V out at this temperature, this is equal to 0. Or simply we can say V negative or V minus, this is equal to V positive. If temperature is lower than 20 degrees Celsius, let me write down here. If temperature is lower than 20 degrees Celsius, LED will be on. But if temperature is greater than 20 degrees Celsius, LED will be off. So this is what it is meant by LED switches on or off at a temperature of 20 degrees Celsius. Very important point you need to understand. If you're not clear about this, it will be very difficult for you to answer this question. Now let's try to understand how we can answer now based on this understanding. V negative is equal to V positive. It means the potential at this point, we know the value of potential at this point. This is V plus. This is equal to 1.6 volt, and V negative at this point, this is also equal to 1.6 volts. Next thing, we need to find out the resistance of this thermistor. But if you look at this graph, at temperature of 20 degrees Celsius, resistance of thermistor is 1.8 kilo ohms. So we can also write down here RT, this is equal to 1.8 kilo ohms. For this question, we need to find out this resistance. Now this is capital R. We need to find out value of this capital R. Now it's a very straightforward question. It's just simple potential divider. We can also connect our voltmeter here. The reading on this voltmeter means the voltmeter across this resistor reading will be equal to 1.6 volt. Now if we need to find capital R, simply we need to use potential divider formula and we can find out. So let me write down, let's say the VR, this potential difference across this resistor, this is VR. So VR simply is equal to the resistance of this resistor divided by the total resistance of this branch, that is R plus 1.8, and potential difference across these two resistors, that is 3.0. If we solve this one, we can, first of all, we need to plug in value of VR, that is equal to 1.6. So we have R divided by R plus 1.8, and this is multiplied by 3.0. Now if we solve this one for value of R, we can find out R will be equal to 2.2 kilo ohms, and that is the answer. That is what we need to find out. We need to find out value of R in kilo ohms. Simply our final answer is 2.2 kilo ohms. Let's try to answer the same question using a different method. We have already discussed potential at this point, V negative. This is equal to 1.6 volts. And potential at this point, this is V plus, and that is equal to 1.6 volts. Potential at this point, this is equal to 3 volts, and potential at this point, this is also equal to 3 volts, and potential here, this is 0 volt. Potential here is also 0 volt because they are just connected by one ideal wire. Next thing we need to understand, if we connect our voltmeter here, let's say we connect voltmeter across this thermistor, the reading on this voltmeter, let's say that is equal to V2, and the V2 will be equal to 3 minus 1.6, that will be equal to 1.4 volts. If we connect our voltmeter here, let's say this is V1, and the reading on this voltmeter, that will be equal to 1.4 volts, means difference between these two. And if we connect our voltmeter here, let's say this is V3, the reading on this one will be equal to 1.6 volts. If we connect voltmeter across this resistor capital R, we can say this is our voltmeter for V4, and this reading will be equal to 1.6 volts. Very straightforward one. From here we can say that V1 is equal to V2. Let's say current I is flowing in this branch, and let's say current I2 is flowing in this branch. Then simply we can say I1 R1. Let's say this resistor is R1, this resistor is R2, and this resistor is R3, and this one, let's say this is R4. We can write down this has to be equal to I2 times R2. From here we can find out I1 over I2. This is equal to R2 divided by R1. We can repeat the same process for V3 and V4. For V3, we can write down I1 R3 is equal to I2 times R4. From here, we can write down I1 by I2. This is equal to R4 by R3. Let's say this is equation 1 and this is second. Now, if we compare these two, simply we can write down R2 by R1. This is equal to R4 by R3. So this is ratio between these resistors. Now simply we can use this one and we can find the value of unknown resistor. In this case R2 resistor, simply let me write down here, R2 by R1 has to be equal to R4 by R3. Let's try to write down this formula in a simpler form. First of all, we need to cross multiply. Means we multiply like this and we multiply like this, cross multiply. So we can write down this is R2, R3, this will be equal to R1 times R4. Let's divide both sides by R3, R4, this side also by R3 and R4. Now from here we can cancel R4, we can cancel with R4, and R3 we can cancel with R3. Now this is the simpler form you can use next time. We can also write down like this, R1 by R3, this is equal to R2 by R4. You need to understand this is R1 and this is R3 and this is R2 and this one is R4. It simply means that the ratio between these two resistors is equal to ratio between these two resistors. The value of R1 now we have, that is equal to 2.5 kilo ohms. We can divide by the resistance of this resistor, that is equal to 3 kilo ohms. And resistance of R2, this is equal to 1.8 is already written here. Let's make some space. This is 2.5. Let me rewrite 2.5 divided by 3 kilo ohms and 1.8. This is the resistance of R2. You can see here divided by R. We can solve this one for R. Our final answer will be 2.2 kilo ohms. So this is our final answer.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss one typical type of question on Hall voltage. But this question is very important for your exam because these type of questions are very common in CIE final exam. And today's question is from May-June 2021.
For part A, we need to state what is meant by a magnetic field. This is very basic question and very common question in many past papers. If you go through different past papers, you will see this question is very common. So you need to understand how to state what is a magnetic field. First of all, let's try to understand little bit about magnetic field if you are not very clear. But this is very basic one, so I will just explain a few points. Let's say this is our bar magnet and we can also draw the magnetic field around this one. So this is magnetic field, you can draw around this one. So you can also add arrows to show direction of magnetic field lines. But you also need to understand magnetic field line does not only stop at the poles, they continue inside the magnet as well. So this is difference between magnetic field and electric field. Now what is magnetic field? Magnetic field simply, this is the region around this magnet in which an other magnet, for example, we have another magnet, let's say this also has north pole and south pole. If we bring this magnet closer to this one, means in this region it will experience magnetic force. On the other hand, we can also bring a charge, let's say this is a moving charge, it has charge on this is a moving charge. If we bring this moving charge, means this moving charge pass through this region, this moving charge will also experience a force. We can also bring a current carrying conductor, let's say this is our conductor and current is passing through this one, and if we bring this current carrying conductor inside this region, this conductor will also experience a force. So this is current carrying conductor. So this is current carrying conductor, we can write down here. So this current carrying conductor will also experience force. So that region what we call is magnetic field. Now let me explain to you how to write your answer. This is how you can write down your answer. You can simply say region of space. Even if you simply say region, you don't say space, that's okay. You can say region of space where a moving charge may experience force, because the moving charge, if it is moving parallel to the magnetic field, it will not experience force. So that's the reason we are saying may experience. Around a magnet, or you can say a region around a magnet where another magnet will experience the force. Means if you have one magnet, let's say this is magnet A, if you bring another magnet inside the magnetic field of this magnet B, this will experience a force. So this is how simply you can define. Very basic idea. I hope it is clear to you what is magnetic field. For part B, aluminium foil is shown in figure 9.1. It is also given to us that the magnetic field is normal to phase PQRS of the foil. Means to this phase PQRS, magnetic field is normal to this phase. Electrons each of charge negative Q enter the foil at right angles to the phase PQTV. So this is direction of movement of electrons. For part 1 on figure 9.1, we need to shade the face of the foil on which electrons initially accumulate. First of all, let's try to write down what is given to us. For this question, we have direction of magnetic field, and that is perpendicular to this face, means that is perpendicular. So this is direction of magnetic field. We can simply write down B, and its direction is vertically downwards. We also have direction of movement of electrons. We can simply say this is electric current due to flow of electrons, and this is to the right. So we can draw a small arrow. So this is telling us current is to the right, and this current is due to flow of electrons. If we can find out direction of magnetic force on these electrons, then we can determine direction in which these electrons will be deflected. So how we can find direction of magnetic force on these electrons? For that purpose, we need to recall Fleming left hand rule. So simply let me write on here. Fleming left hand rule we can use for conventional current, means due to flow of positive charges. So this is conventional current. We can use when we have direction of conventional current. So conventional current and magnetic field, direction of magnetic field and force. When we have two of them, we can find the third one, and this is the force. So this is simply force. This is force. In Fleming left hand rule, the thumb points in direction of force and first finger. So we can write down the first finger. This points in direction of magnetic field. We can write down first finger, and the middle finger. For conventional current, we use middle finger. So we can write down middle finger for conventional current. Simply, we need to use our left hand and we can find direction of force on positive charges. So we will assume this one. If this was a positive charge, so let's say if this was a positive charge, now we can use Fleming left hand rule and we can find direction of magnetic force on positive charge. Electron has opposite charge, so direction of force on electrons will be in opposite direction. Let's try to use the left hand rule right now. You can see here now, in this case, magnetic field is down. As you can see here, I have already drawn here. This is direction of magnetic field. In this case, the flow of electrons, we are assuming electron is a positive charge now. So this is to the right. So this is direction of positive charge, so this is to the right, and the force is pointing this way, so the force is pointing into the page. So I will just draw small cross here into the page. So if it was a positive charge, but it is electron, so the force on this electron is out of the page. So we can assume if electron was here, it will experience force this way. So this is direction of magnetic force on electrons. So this side, electrons will accumulate on this side. So this side will be negatively charged. So simply we can write down our answer. The phase PSWV, electrons will be accumulated on this phase PSWV. For part B2, we need to explain why electrons do not continuously accumulate on the phase you have shaded. It simply means that at the beginning, electrons will accumulate on this phase PSWV, but that will happen for a very short period of time. After that, electrons will continue moving in a straight line. We need to explain why it is happening. First of all, let's try to understand when this side become more negative as compared with this side, electric field will set up between these two phases. Means accumulation of electrons will cause electric field. So electric field will set up like this between these two phases. Let me draw another electric field lines. So the first point we need to understand, accumulation of electrons, it will cause electric field. So we can write down accumulation of electrons causes electric field. So this is the first point, causes E field. I will simply write down causes electric field between these two phases. The second thing we need to understand, there is electric field. Electron is also in the electric field now. This electron will also experience electric force. Electron will experience electric force, and that force is opposite to magnetic force. Electron experience electric force. So second point, we can write down electron experience electric force, and this electric force will oppose the magnetic force. We can also write down Fe opposes magnetic force. So Fe opposes Fb. Finally, Fe will be equal to Fb. Finally, after a certain period of time, Fe will be equal to Fb. At that time, there will be no more accumulation. Means electrons will not accumulate. No more accumulation. We can simply write down. And electrons, they will just go in a straight line. This is what we need to write to answer this question. This question has 3 marks. So if we mention these 3 points, you will get 3 marks. Now let me show you how to write a proper answer. This is how you can write down a proper answer. As you can see here, I have written in detail. So you can see first point, accumulating electrons cause an electric field. Electric force due to electric field opposes magnetic force, as we have mentioned here. And the third point, accumulation stop when these two forces are equal. For part C, expression for Hall voltage is given, and this is the expression, means this is the formula for Hall voltage. VH here, this is the Hall voltage. So let me write down here. VH here, this is representing Hall voltage.
Hall voltage. I here, I is the current in the foil, so I is the current. V is the magnetic field density, or we can say this is magnetic flux density. So this is magnetic flux density or magnetic field density P. You need to understand all these symbols, the meaning of these symbols. And here, this is for number density of charge carriers. So this is number density of charge carriers. Number density of charge carriers, or simply you can say number density. It simply means that the number of charge carriers per unit volume. So this is number density of charge carriers. We can write down T here. This is the thickness. The T here for thickness. This is thickness of side through which magnetic field is passing. For example, in this case, this is our magnetic field, and the magnetic field is passing through this side. So magnetic field is passing through this side. So T is the thickness of this side. So this is the T, thickness of side through which magnetic field is passing. So that is T. Q is the charge on single electron. This is a constant. So this is 1.6 times 10 to negative 19 coulomb. Negative 19 coulomb. So this is what we need to understand about Hall voltage formula. Now let's try to answer the first one. It's simply asking you meaning of quantity N. We have already mentioned this is number density of charge carriers. And the next one is asking us using the letters on figure 9.1, identify the distance T. So the distance T, this we need to identify. Simply we can write down this distance is equal to PV, or you can say this is equal to SW. You can also say that this is equal to QT, so we can also write down this is equal to QT. So this is how you can write down your answers. Simply you have to write down number density of charge carriers, PV, SW, even you can write QT. For part D, we need to explain why Hall probes are made of semiconductor material, not made of metal. For that purpose, we need to understand the expression for Hall voltage. VH Hall voltage, this is equal to BI over NTQ. Now let's say we have two different pieces, one made of semiconductor. So let's say this is piece of semiconductor. So simply we can write down, let's say this is piece of semiconductor, and the second piece, this is made of metal. So this is made of metal. If we look at this formula, let's say the thickness of these two material is the same. T means the distance traveled by magnetic field in semiconductor, and the distance traveled by magnetic field in metal means T is the same. Then this is B, this is the external magnetic field, that is the same for metal, that is also same for semiconductor. Current, this is provided by power supply, this is also the same. Q is a constant, so this Q is a constant, so this is also same. If T means T, we have to keep same for these two materials. I mean the distance traveled by magnetic field in semiconductor and metal also has to be the same for a fair test. Then only one property is left, that is N. That will be different for semiconductor, and also that will be different for metal. If this N is small, then Hall voltage will be large. For semiconductor, this N is much smaller, so the VH is much larger. That's the reason Hall probes are made of semiconductor instead of metals, because N, the number density for them is lower, so Hall voltage is greater for the same thickness in the same magnetic field for the same amount of current passing through foil. Now let me explain to you how to write the answer. So this is how simply you can write down the answer. You can say for semiconductor N is much smaller, so the VH is much larger. Only one mark. If you just write down this 1 point, you will get 1 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetic induction from May-June 2021 paper 4.1. In this question, I will explain you what is Lenz's law, what are eddy currents, and what is eddy pendulum. For part A, we need to state Lenz's law. First of all, let's try to understand Faraday's law, because understanding of Faraday's law is very important to understand Lenz's law. According to Faraday's law, induced EMF is proportional to rate of change of flux linkage, and this is symbol for flux linkage, rate of change of flux linkage. But according to Lenz's law, induced EMF is equal to negative n delta phi by delta t. This is also another way to write flux linkage. Lenz is in fact simply added this negative sign, and that's all about Lenz's law. We need to understand what is significance of this negative sign. This negative sign is simply telling us that induced EMF opposes the change in flux, or you can say opposes the rate of change of flux. This is all about Lenz's law. Let me explain to you this one in a little bit different way. These two laws together, we can simply write down change of flux. If conductor is placed and there is a change of flux, then there will be induced EMF, means EMF will be induced. Change of flux in a conductor produces induced EMF, and this is what is Faraday's law. Faraday's law is telling us about this. But Lenz's law is telling us that induced EMF opposes the change of flux, and that is Lenz's law. Let's try to understand a little bit more about Lenz's law with the help of this simple apparatus. Here you can see we have a magnet, and this magnet is approaching a ring, and this ring is made of metal. It simply means it is conductor. As this magnet is approaching, you need to understand what is changing here, mean inside this conductor. As magnet is approaching, the magnetic field inside this conductor is increasing, means magnetic field here, it is getting stronger and stronger. So there is change in magnetic field, or we can say there is change in magnetic flux. If there is a change in magnetic flux, means magnetic flux is changing with time, there will be induced EMF, and that is according to Faraday's law. If there is rate of change of flux, means flux is changing with time, EMF will induce. So in this case, EMF will induce. When EMF induced, current will also flow, means there will be induced current, because this is a closed loop, it's a closed circuit. Current will flow. When current flow in any conductor, there is also a magnetic field around that conductor, means current produce its own magnetic field. We have discussed this one many times in electromagnetism, means electricity can produce magnetism. If you look at this wire, for example, in this wire, if current is flowing upwards, there will be magnetic field around this wire, and in this case that will be in counterclockwise, mean anti-clockwise. And this direction of magnetic field simply we can find out with the help of right hand grip rule. Simply we need to use right hand grip rule, and we can find direction of magnetic field. In this case, now we need to understand direction of magnetic field, because if you look at Lenz's law, induced EMF will oppose the rate of change of flux. So how this can oppose the rate of change of flux? In this case, B external, this is increasing. So current will flow in such a way that it will produce its own magnetic field to reduce the change in flux. Mean it will try to minimize the magnetic flux here. How it can minimize? It can minimize simply by producing its own magnetic field in the opposite direction. So if N is entering, so this end of induced magnetic field has to be N here. So N oppose N, and other end will be S. Now we understand direction of magnetic field N, and we can find direction of induced current. Again, we need to use right hand grip rule. We can find out direction of induced current. In this case, this will flow in counterclockwise, and that's all about Lenz's law. Now let me explain to you how you can write down a proper answer, or at least the points you need to mention in your answer to get full mark. The first point you need to mention is direction of induced EMF, or you can say direction of induced current. If you will mention this one in your answer, you will get 1 mark, and this is M mark. It has to be in your answer. If you can't get M mark, you also cannot get A mark. So it's very important. Whenever you state Lenz's law, you need to mention direction of induced EMF, or you can say direction of induced current. And the second mark you will get if you have mentioned is such as to oppose the change causing it. You can write down in a little bit different way that you need to mention change, because this is underlined and it has to be in your answer. If you will write down your answer like this, you will get these 2 marks. For part B, it is given to us a metal ring is suspended from a fixed point B by means of a thread as shown in figure 10.1. So this is figure 10.1 and this one is metal ring. It is suspended from this fixed point P. It is also given to us the ring is displaced a distance D and then released. Ring completes many oscillations before coming to rest. Next, it is given to us the poles of a magnet are now placed near to the ring so that the ring hangs midway. As you can see here, this ring is between these magnetic poles. It is placed midway. The poles of the magnet as shown in figure 10.2, as you can see in this figure. The ring is then again displaced a distance, means the same distance, and then released. But this time the ring completes only fewer oscillations before coming to rest. We need to explain why. Now we need to understand if it complete less number of oscillations, it means that there is kind of opposing force that will do negative work and take energy away from this ring. That's the reason this ring just complete few oscillations. We can explain this one based on 2 different concepts. First, we can explain this one based on forces. The second way to explain this one is based on conservation of energy. We will follow these 2 approaches to answer this one. First of all, let's try to answer this question based on conservation of energy. In the question, it is given to us the ring is displaced by a certain distance d. When we displace this one by a certain distance d, it will gain gravitational potential energy. When it will come back to this position again, gravitational potential energy, this will be converted into kinetic energy. Or simply we can say the ring has mechanical energy. First of all, when this ring will cut the magnetic field lines, it means flux will change. So simply we can write down here flux change. When it will cut the magnetic field lines, flux will change. When the flux changes, EMF will be induced in this ring, or we can say in this conductor. When EMF is induced, there also will be induced current, or simply we can say eddy currents will produce. When eddy currents produce, it simply means that the mechanical energy, it has been converted into electrical energy. So we can simply write down mechanical energy will be converted into electrical energy. But we also need to understand the ring has its own resistance. It has resistance, so due to resistance, electrical energy, ring has resistance. So simply we can write down the ring has resistance. So electrical energy, this will be converted into thermal energy. So we can write down electrical energy will be converted into thermal energy. And this thermal energy, this is coming from the mechanical energy, and that is energy of this metal ring. So finally, energy of the ring will decrease. So when energy of the ring will decrease, it will complete few oscillations. So that's reason it will complete fewer oscillations, because mechanical energy, it has been converted into electrical energy, and the electrical energy has been converted into thermal energy because ring has resistance, and the energy of this ring will decrease. That's reason this will complete few oscillations. So these are the points simply you need to write down to answer this question. Let's try to understand the same question, means try to answer the same question with the help of forces. For that purpose, we need to imagine that, first of all, when the ring is outside, means when we displace this ring. In this case, I'm drawing this rectangular ring instead of circular because it is easy to understand with the help of rectangular. But concept is the same. When the ring is here, when we displace this ring by a certain distance d, it is here. It is outside of the magnetic field, so there is no magnetic field here. Next thing we need to understand, when the ring is at this point, means when the ring is entering into this magnetic field, so there is a change in flux. So there is change in flux at this point. As there is a change in flux, and this is made of metal, it's a conductor, there will be induced EMF according to Faraday's law. But this is also a complete circle, so there will be induced current as well. So I'm just saying this one for simplicity, so it's easy to understand. Even it is just a solid conductor, there also will be eddy currents. They will flow inside this solid conductor as well. To keep it simple, I'm saying this is a complete circle, means this is a closed loop. There will be induced current. Now we need to understand what is direction of induced current. For that purpose, we need to understand direction of B external. So this is B external. So this cross is telling us the magnetic field, means the external magnetic field. This is into the page. But when this is entering into this magnetic field, the external magnetic field is increasing. According to Lenz's law, this conductor, means this conducting loop, this will oppose the change in flux. So it will oppose the change in flux. Now how it can oppose the change in flux, means how it can reduce the magnetic flux or magnetic field inside itself. It has to create its own magnetic field, and that magnetic field, means induced magnetic field, has to be out of the page, means opposite, and this is induced magnetic field, means current will flow in this loop in a way that its own magnetic field will be opposite to the external magnetic field, means magnetic field will be out of the page. So we can draw these dots with circle here. Magnetic field is out of the page. Now we understand magnetic field is out of the page, so we need to find direction of current. So for that purpose, we need to use right hand grip rule. We can simply use, and we can find out direction of induced current. If we use right hand grip rule, direction of current on this side, it will be downwards, means here direction of current is downwards. So we can write down direction of current is downwards. Now we need to use Fleming left hand rule. So let me write down here Fleming left hand rule. Now we have external magnetic field. Direction of external magnetic field is into the page, and direction of current here, this is downward. So what is direction of force? Simply you need to use left hand rule, and direction of force will be to the right, means there is opposing force on this loop, so that will oppose the motion of this one. It will slow down. Now the same we need to understand, when this is leaving, when this is at this point, just gonna leave now. Now we need to understand the magnetic field inside this will increase or decrease. External magnetic field, now it will decrease. So we can write down external magnetic field will decrease, and external magnetic field is into the page. Now this conductor, again it will oppose the change, but in this case external magnetic field is decreasing, so it will try to maintain the magnetic field or magnetic flux. So the B induced, in this case it has to be in the same direction as external magnetic field. So we can draw these
crosses here, means current will flow in this loop again in such a way that it will oppose the change. Now how it can oppose the change? Magnetic field is decreasing, it will support actually, so it will produce its own magnetic field in the same direction. So again we can use right hand grip rule here. We can find direction of current in this. If we use right hand grip rule, we can find direction of current. So current will flow here downward. So current will flow downward on this side. Now current is downward and external magnetic field again, this is into the base. So there is opposing force on this. So this will oppose the motion. It will slow down. So if you look at this side, work done by the magnetic force is negative. So it means this loop will lose energy, means its mechanical energy will decrease with time and finally it will stop. So that's how we can explain with the help of forces. Now let me explain to you how you can write down a proper answer. These are the points you need to write a good answer. In your answer, if you have mentioned ring cuts magnetic flux, or if you have mentioned magnetic flux inside the ring is changing, and also you have mentioned it causes induced EMF in ring, you will get first B mark. The second mark you will get if you have mentioned induced EMF causes currents in ring, you will get the second B mark. And the third mark is M mark. If you have mentioned currents in ring dissipate thermal energy, you will get this M mark. But this M mark is very important because next A mark is depending on that. If you cannot get M mark, you will also not get A mark. So very important point. Next, if you have mentioned thermal energy comes from energy of oscillation, you will get A mark. So here is how you will get these 4 marks. But you can also write down based on forces. You can write down the M mark. Currents in ring causes magnetic field around ring, you will get M mark. And then if you have written two fields interact to cause opposing force, you will get A mark. This is how marks will be awarded. So you have to write these points in your answer. For part C, it is given to us the ring in B is now cut as shown in the figure. As you can see here, there is a cut in this ring. So this is not a complete ring now. Question is asking us, we need to explain why when the procedure in B is repeated, the cut ring completes more oscillations as compared with the complete ring. When oscillating between the poles of the magnet, we need to explain now why this will complete more oscillation as compared with complete ring. When it is oscillating in the magnetic field, means they are oscillating in the same magnetic field. In order to answer this question, we simply need to understand one very basic concept, and that is about current. There is a cut, so it means current cannot pass all the way around the ring, but still there will be eddy currents, and amount of eddy currents will be smaller. So we can write down smaller amount of current will produce because there is cut in the ring, so smaller amount of current. If smaller amount of current, it also means that amount of electrical energy produced, that will be smaller. If amount of electrical energy produced is smaller, then the amount of thermal energy produced per given time, that will be smaller. If the amount of thermal energy produced per given time, that is smaller, it means that less amount of mechanical energy is converted into thermal energy per unit time, means in any given time. So the rate of energy transfer is lower. If the rate of energy transfer is lower, this ring will take longer time to stop. That's the reason it will complete more oscillation. That's all what we need to understand to answer this question. These are the points you need to write down a proper answer. If in your answer you have mentioned that current cannot pass all the way around the ring because there is a cut, you will get first B mark. And the second B mark is if you have written induced currents are smaller, so means less amount of current will be
induced, you will get second B mark. And the third B mark is you can write down smaller resistive forces, because if current is smaller, resistive forces are smaller, so more oscillation, or you can mention smaller rate of dissipation of energy, so more oscillations. So these points you need to write down to get full marks. Means 3 marks for this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper question from May-June 2021 paper 4-1. This question is about medical imaging, one of the most challenging topic for many students at this level. In this video, I will explain you this question step by step and in detail, so you can have clear understanding how to handle this type of problems in future. For part A, simply we need to state how in a modern X-ray tube, intensity of X-ray beam and its hardness are controlled. Control means that how we can increase the hardness or how we can decrease the hardness. That is also true for the intensity of X-ray, means how we can control the intensity of X-ray. It simply means that how we can increase the intensity or how we can decrease the intensity. This is what question is asking us. First of all, let's try to understand what is intensity. We need to understand these terms, what exactly it means by intensity. Intensity, when we talk about intensity of X-ray beam, it means we are talking about the amount of X-rays. So this is the first thing you need to understand. Intensity refers to amount of X-rays. Amount of X-rays, we can also understand, it depends on number of electrons. Number of electrons hitting the anode. Number of electrons we can write down hitting the anode per unit time. Hitting the anode per unit time. It simply means that here is our anode. You can see this one is the anode. So this is anode. How many electrons are hitting this one per unit time? If the number of electrons hitting this anode per unit time is greater, it means intensity is higher. If less number of electrons are hitting this anode per unit time, it means intensity is lower. So this is what is meant by intensity. What is benefit of intensity? If the intensity is higher, means the intensity of X-rays is higher of X-ray beam, it simply help to produce image quickly. We can form image of object quickly. So that is the benefit of higher intensity. Question is asking us how we can control this intensity. This intensity, as I mentioned here, is depending on the number of electrons, and the number of electrons, they are depending on this filament. If we heat up this filament more number of electrons will be emitted. In order to emit more number of electrons, we need to increase the filament potential difference across filament. So this is our filament. So here is the potential difference. We have to increase this potential difference. If we increase this potential difference, more number of electrons will be emitted. It means the intensity will be higher. So we can say intensity will be higher, and vice versa is also true. If we decrease this potential difference across filament, intensity will go down because less number of electrons will be emitted from this filament. So this is what you need to understand about intensity. Let's try to understand what is hardness. When we talk about the hardness of X-rays, so what exactly it means? When we are talking about the hardness of X-rays, it means we are talking about the penetration power of X-rays. Simply means that if they have higher penetration, it means the energy is greater, means the energy of photon is greater. And energy of photon, it depends on frequency of X-rays, or simply we can say the frequency of X-rays. If X-ray photon, they carry more energy, it means the frequency is higher. As we understand, energy of photon, this is equal to hf. Higher the frequency, higher the energy. If the energy is greater, it means the penetration power is greater,
or we can say the hardness is greater. Now the question is that how we can give more energy to X-rays, means how we can produce more energetic X-rays photon, and that is depending on the acceleration of electrons emitted from the filament. If we apply higher voltage between cathode and anode, as you can see here, this is the potential difference between cathode and anode. If this potential difference is greater, then these electrons, they will gain higher kinetic energy, means the speed will be higher. If the speed will be higher, it also means that we have accelerated more, or we can simply say it depends on acceleration of electrons. Acceleration of electron, if we accelerate these electrons more between cathode and anode, it means electrons will gain more kinetic energy, and when they will hit this anode, they will produce higher energy X-ray photons. This is how you can write down your final answer. You can simply say that by varying potential difference across filament, means this potential difference, if you vary this one, you can control the intensity of X-rays. In order to control hardness, you need to mention that by varying accelerating potential difference, it means that the potential difference between cathode and anode, this potential difference, by increasing you can increase the hardness, by decreasing you can decrease the hardness, simply you can control. And here by increasing the potential difference across filament, you can increase the intensity, or by decreasing potential difference you can decrease the intensity. This is how you can control. But if you look at the marks, this is B mark, means this independent mark, so this must be seen in your answer, so you have to be careful, you have to mention this one. You can mention current, or you can say PD across filament. This mark is also B mark, this has to be in your answer.
For part B, a model of a limb consists of soft tissue and bone. As illustrated in figure 11.1, this is figure 11.1. Soft tissue has a thickness of 9.0 centimeters and bone has a thickness of 3.0 centimeters. Data for the linear attenuation coefficient of X-rays in soft tissue and bone is given in table 11.1. For soft tissue, this is 0.92 per centimeters, and value of mu for bone is 2.9 per centimeters. As you can see here, the value of mu is greater. It means that the bones are very good at absorbing X-rays. So that is also a very important point you need to understand. For part D1, we need to calculate intensity IS through soft tissue only, but it has to be in terms of I naught. This is very straightforward question. It's simply asking you to use linear attenuation equation, means I is equal to I naught e to the power of minus mu x. Mu here is absorption coefficient and x is the thickness, so let me write down here. So this one is the thickness, this is the thickness. I naught, this is the incident intensity, so this is incident intensity. You need to understand what these symbols are telling you. So this is the incident intensity and this is the transmitted intensity. So this is transmitted intensity. Transmitted. It simply means that if you look at this given figure, in this case incident intensity, this is equal to I naught, and transmitted intensity, this is IS. Question is asking us to find IS in terms of I naught. We can rewrite our equation now, so it simply means transmitted intensity, this is IS, and incident intensity, this is I naught, e to the power of minus mu x, and the value of mu for soft tissue is given, that is 0.92, so simply we can
plug in value of that. That is 0.92. We also need to plug in value of x, the thickness. A thickness is given, that is 9.0 centimeters, means only the thickness of soft tissue, that is 9.0 centimeters. So this is 9.0 centimeters, but in this case they have the same unit, so that is right. But if they have different units, you have to convert units as well. Now simply we need to solve this one for is, and we will get our final answer. If we solve this, our final answer will be 2.5 times 10 to negative 4 I naught. And this is our final answer, and this is transmitted intensity through soft tissue only. There are 2 marks for this question. Let me explain to you how these marks will be awarded. First mark is C mark. You will get C mark if you have written this equation. And the second mark is for the correct answer. If your answer is correct, you will get another mark. So there are 2 marks in total for this question. First mark is C. If your answer is even wrong, but you have written the equation, you will get 1 mark. But if you got the right answer, you will get these 2 marks. So this is how marks will be awarded for B1. For part B2, we need to calculate the transmitted intensity IC through soft tissue and bone. But our answer has to be in terms of I naught. Now if you look at this figure, we have incident intensity, that is I naught. First of all, this will pass through the soft tissue, then it will go through bone, then again it will pass through soft tissue, and this is the transmitted intensity what we need to calculate in terms of I naught. We can answer this question using different methods. We can use a simple method or we can use a complicated one. We will use simple method for this problem so you can understand well that method, and next time you can use by yourself to answer same type of problems. First of all, look at this diagram. You can see here the red part. This is representing the soft tissue. So this is the soft tissue. And the second part, this is representing bone. And the third one, this is representing soft tissue again. So this is soft tissue. So as you can see here, first of all, we have soft tissue, then is bone, then is soft tissue. So I have just drawn here to give you better picture of this question. Now we can combine these two together. I mean the soft tissue we have here and soft tissue we have here. We can combine these two. So you can see I have combined these two here. So this is the soft tissue. The thickness of this soft tissue, this is equal to 6.0 centimeters, and the thickness of bone, this is 3.0 centimeters. As you can see here, the total thickness is 9.0 centimeters and the thickness of the bone is 3.0 centimeters. So the thickness of soft tissue is 6.0 centimeters. It is also given to us the incident intensity is I naught. Now let's say the transmitted intensity after passing through the soft tissue is I1, and the transmitted intensity after passing through bone, that is IC, and this is what we need to find out. Now simply we need to use linear attenuation equation 2 times to calculate the value of IC. First of all, we will use attenuation equation for I naught and I1. So I naught is the incident intensity and I1 is the transmitted intensity. So simply we can write down I1 has to be equal to I naught times e to the power of mu x, negative mu x. I naught, we just need to write down I naught, the value of mu is given. For soft tissue, value of mu is given, that is 0.92. We can also use negative sign here. So 0.92. And the thickness of soft tissue is 6.0 centimeters. So this is value of I1. But again, now we need to use linear attenuation equation for this I1 and for IC. But now here, this is a little bit tricky one. IC now, this is the transmitted intensity. We can write down this one is transmitted intensity. So this is transmitted intensity. This is transmitted intensity. But incident intensity now, this is I1. So this is incident. So let me write down here. This one is the incident intensity. Now simply we need to use equation and we can find the answer. Now in this case, our transmitted intensity, this is IC. But incident intensity, that is I1. Again, it has to be multiplied with e to the power of negative mu x, but I1 is equal to this. So we have to replace I1 with I naught. I will just use bracket here, and this is e to the power of negative 0.92 times 6.0, and this is multiplied with e to the power of negative mu, and this mu is for the bone, that is 2.9, and the thickness of the bone is given, that is 3.0 centimeters. Now simply we need to solve this one and we can find the final answer, the value of IC. If we solve this, our final answer will be 6.7 times 10 to negative 7 I naught. That's all what we need to do. Very simple one. Simply you need to understand how to use this equation. Which intensity is the incident and which one is the transmitted. By reference to our answers in B, we need to suggest with a reason whether good contrast on an X-ray image would be obtained. For that purpose, we need to use our answers from part B. In part B, we have calculated value of IC. We have also calculated value of IS. First of all, let's try to look at the ratio between IS and IC. IS divided by IC. IS is 2.5 times 10 to negative 4 I naught, and IC is 6.5 times 10 to negative 7 I naught. So I naught we can cancel. So the approximate answer what we will get from here, so the ratio will be equal to about 1000. So it simply means that IS is about 1000 times greater than IC. Very high value of IS and very low value of IC are simply telling us if we place a photographic film at the back of this part of the body, the part behind, means the part of the photographic film behind the bone, it will stay white because less number of photons will reach this part, less number of photons, but the number of photons, X-ray photons, reaching where is no bone will be very high number of X-ray photons. So this part will be black, this will be dark, and this part will be white, it will stay white. So this will be too dark, we can simply say the part behind the soft tissues will be too dark, and the part behind bone, it will be less dark. So we can say this will be less dark, or simply it will stay white. So that's the reason there will be very good contrast. So in this case we can say there will be very good contrast. Why? Because IS is much greater than IC, and that's our answer. We can write down here there will be good contrast, and then we need to explain why. So the explanation, the reason is that because IS is much greater than IC. This image is a great example of good contrast. Simply you can imagine that the part behind the bone, so this is the part behind the bone, so this is what we will see on the photographic film. We will see the white part, so this is the part behind the bone, so we will see the clear image of bone, but the part behind the soft tissues is this one, so this part will be too dark. So this is a great example of good contrast, means the background is too dark and the area behind the bone, that is white. So this is great example of good contrast, and this is what you will see on the photographic film.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on quantum physics from May-June 2021 paper 4.1. For part A, it is given to us electromagnetic radiation of a single constant frequency is incident on a metal surface. This causes an electron to be emitted. We need to explain why the maximum kinetic energy of the electron is independent of the intensity of the incident radiation. This question is simply asking us why the maximum kinetic energy of the electron is not depending on the intensity of the incident radiation. We need to be very clear what does it mean by energy of the photon and what does it mean by intensity of the incident radiation, and then we can answer this question. First of all, let me explain to you what is energy of a single photon and what is intensity of the incident radiation. Energy of single photon, simply we can write down capital E, this is equal to hf. H is Planck's constant and f is frequency of incident radiation. We can simply say this is frequency of radiation. E is energy of single photon. We can also write down energy of photon in terms of wavelength. We can say this is hc over lambda. So lambda is the wavelength of incident radiation. F is equal to V over lambda. So here we are talking about electromagnetic radiation. So this is C over lambda. Next thing we need to understand what is intensity of incident radiation. Intensity, very important concept and often misunderstood by many students at this level. Intensity is equal to power over unit area, and power we can write down power is equal to energy over time. So intensity is equal to E over T times A. So E here, this is energy of incident radiation. That incident radiation, it consists of many photons. So we can replace this E with N times E, and here now this E is energy of single photon divided by T times A. E here is energy of single photon. So this is energy of single photon. Let me write down. You have to be very clear about this. This is energy of a photon, or simply you can say energy of single photon. N is representing number of photons. So here N is representing number of photons. If you look at this E, I simply wrote E here. You can say that this is energy of radiation. That here this E is representing, this is energy of single photon because radiation consists of more than one photon. That's the reason I multiply with capital N. N is number of photons. So N is number of photons. Now you need to understand, if we increase N, you can see if we increase this N, it means intensity will increase, but energy of photon is not changing. This is the main concept you need to understand. If we increase number of photons, I is increasing, but energy of each photon is same. It is not changing, and this is the concept we need to explain. In order to answer this question, we also need to understand the relationship between energy of a photon, means energy of single photon, and maximum kinetic energy of single photoelectrons. Energy of single photon we can write down, this is equal to hf. Hf is equal to work function plus kinetic energy maximum of single electron. Work function for any given metal, that is constant, so simply we can say this is constant. Kinetic energy maximum, we need to understand why we call this is kinetic energy maximum, because we are talking about electrons released from the surface. It also means that the energy of photon is used to release electron from the metal, and rest of the energy of the photon becomes kinetic energy of electron. If we look at one single photon here, so this photon has energy hf. We can draw this
circle here. So this has energy hf. Some of its energy is used to release electron from the surface. Let's look at this electron. It's used to release this electron from the atom, or you can say from the metal, and rest of the energy of the photon becomes kinetic energy of this electron. And the interaction between photon and electron is 1-to-1, means one electron can only absorb one photon but not more than one. Now, if we increase the frequency of photon, means if we increase energy of photon, as work function is constant, so kinetic energy maximum of photoelectron, that will increase. And this is what we need to understand. Now, if you have understanding of these points, it is very straightforward to answer this question. If I look at this question, it is telling you why maximum kinetic energy of electron is independent of intensity. Because maximum kinetic energy of electron is depending on energy of photon. It does not depend on intensity. If we increase intensity, for example, as I have explained here, if we increase intensity, it simply means that we are increasing the number of photons, but we are not increasing energy of single photon, because energy of single photon is depending on frequency of incident radiation. Now let me explain to you how you can write down a proper answer, or simply I can say the points you need to get full marks. If in your answer you have mentioned that frequency determine energy of photon, or simply you can say energy of photon depends on frequency of incident radiation, you will get 1 mark, and this is B mark. It has to be in your answer. The second point, if you have written in your answer intensity determines number of photons per unit time, as we have already discussed, intensity depends on number of photons per unit time. If energy of photon is constant, is fixed. The third point, you need to write down kinetic energy of the electron depends on energy of one photon. This is very important. If you look at this electron, the kinetic energy of this electron for the same metal, it is depending on energy of single photon, because between electron and photon interaction is 1-to-1. Simply you need to write down these 3 points, and these are B marks. If you have mentioned these points in your answer, you will get full marks. For part B, it is given to us ultraviolet radiation of wavelength 250 nanometers is incident on the surface of zinc. Maximum kinetic energy of the emitted electrons is given, that is equal to 1.4 electron volt. It simply means that lambda of each photon is given, that is 250 nanometers, and kinetic energy maximum for each emitted electron is also given, that is 1.4 electron volt. For part B1, question is asking us, we need to determine the energy of a photon, and energy of photon is simply equal to hc over lambda. H is Planck's constant and c is speed of light. Value of Planck's constant you can get from data list, that is 6.63 times 10 to minus 34. And the speed of light, this is 3 times 10 to 8 meters per second. Lambda is given in nanometers, so we need to convert into meters, so we need to multiply with 10 to negative 9. If we solve this one, we will get our answer in joules, that will be equal to 7.96 times 10 to negative 19 joules. But this is not final answer. We need to convert this one into electron volts. 1 electron volt is equal to 1.6 times 10 to negative 19 joules. From here we can write down 1 joules is equal to 1 electron volt over 1.6 times 10 to negative 19. Now simply we need to multiply this one with 1 electron volt divided by 1.6 times 10 to negative 19 joules. Now joules we can cancel, and if we solve this one, 10 to negative 19 we can cancel with 10 to negative 19. Now simply we need to divide 7.96 by 1.6.
We can assume this is 8.0. If you divide by 1.6, so our answer will be 5.0 up to 2 SF, and this is our final answer. Let me explain to you how marks will be awarded for this part. You will get first C mark if you have written this equation, and the second C mark you will get if you have calculated your answer in joules, and this is correct answer. Third mark is answer mark. This mark will be awarded if you have got the correct answer in electron volts. But if your final answer in electron volt is wrong, but you have written these 2 points, you will still get 2 marks. So it's important to write down all the steps. Let's move on to second part. For the second part, we need to calculate work function energy of the surface of the zinc. We need to understand photoelectric effect equation to answer this question. According to photoelectric effect equation, that is based on conservation of energy, HF is equal to 5 plus kinetic energy maximum, and this is kinetic energy maximum of electron. We need to be clear about this, and this is energy of single photon. Question is asking us to calculate the value of work function. Simply we can rearrange this one. We can write down phi, this is equal to HF minus kinetic energy maximum. Kinetic energy maximum, HF we have calculated, that is 5.0 minus kinetic energy maximum of emitted electrons is given, and that is equal to 1.4 electron volts. Simply we need to subtract, and our final answer will be 3.6 electron volts, and this is the answer for this part. Let's try to understand how marks will be awarded. You will get first mark, and that is C mark if you have written this equation, so you will get C mark. And the second mark is answer mark. If you have got this correct answer, you will get the second mark.